Hi, listeners. This is the 80,000 Hours podcast, where we have unusually in-depth conversations about the world's most pressing problems, what you can do to solve them, and our awesome new theme song. I'm Rob Wiblin, head of research at 80,000 Hours. AI is once again all over the news, thanks to the launch of ChatGPT from OpenAI. ChatGPT has really taken chatbots to a new level in terms of the quality and the coherence of the answers that it can give to seemingly almost any sort of request. People are still exploring and figuring out what ChatGPT is able and not able to do. It can write poetry, script TV shows, code programs, draft newspaper articles, simulate interviews between hosts and guests. It's not at the level of a person yet, and it does have some particular weaknesses, but in many situations, it's getting close. The rate of improvement in these large language models over the last few years has been simply staggering, in my opinion, and seems like many users agree because watching Twitter, people have just been blown away. If you haven't seen it, you can try it for yourself at chat.openai.com, though they are struggling to keep up with really high levels of demand, so you might have to wait in a queue to get access. All that makes me very excited to be releasing this interview with Richard Ngo, who works at OpenAI and researches various issues to do with how very advanced AI can be developed, deployed, and integrated into society while avoiding all of the ways that might go very wrong. We talk about large language models like ChatGPT, among other sorts of machine learning models, including how they work, the capabilities they're gaining, whether or not they can really reason and understand things, and whether there's much to worry about. In the second half of the interview, we turn to Richard's new paper from August, titled The Alignment Problem from a Deep Learning Perspective. Note that this conversation was recorded a couple of weeks before ChatGPT was released, so I don't name it or bring it up specifically. I'm always worried these conversations about AI are going to get too technical, and I'm going to struggle to follow, which would be a red flag that maybe some listeners are also going to struggle to follow. But I was really happy listening back to this one, that I think we both explain some very important ideas that most listeners won't have heard before, while remaining still pretty easy to keep up with. Before that, one very important announcement. We have a lovely new theme song called La Vita e Bella, I hope I'm pronouncing that right, by Jazz Enough from their 2020 album Magic Carpet. I'm a big fan of Jazz Enough, so I hope you enjoy it and that one day it generates a Pavlovian response where you start salivating for in-depth conversations about the world's most pressing problems and what you can do to solve them every time you hear it. Their new album out this year is called Sundance, and of course you can go and find that anywhere you get music. Oh, and the runner-up option for our theme music was the track Coffee and Cigarettes, also from Jazz Enough. So go check it out and do email us if you think we've made a mistake so that we can feel bad about our choice. All right, without further ado, I bring you Richard Ngo. Today, I'm speaking with Richard Ngo. Richard grew up in Vietnam and New Zealand before moving to the UK to study computer science and philosophy at Oxford and a master's in machine learning at Cambridge. He then became a research engineer on the Artificial General Intelligence Safety team at DeepMind, then spent a year on a PhD in the philosophy of machine learning at Cambridge on the analogy between the development of artificial intelligence and the evolution of human intelligence. But in 2021, he dropped the PhD and moved on to research AI governance at OpenAI, the organization responsible for GPT-3 and DALL-E 2. Richard is a prolific writer on the risks created by rapid advances in machine learning and how to ameliorate them across published papers, the AI Alignment Forum, the Effective Altruism Forum, and of course, Twitter. His current goals are to understand the key patterns of the world, to help make the long-term future of humanity amazing, and hopefully to stick around to enjoy it himself. Thanks for coming on the podcast, Richard.
Thanks so much for having me, Rob. I'm a big fan. Really excited to be here.
Fantastic. I hope to talk about recent progress in the field and some things listeners should understand about how ML models actually work. But first, what are you working on at the moment and why do you think it's important?
So right now I'm splitting my time a few different ways. So I'm on the governance team at OpenAI and we're basically trying to figure out what the governance and regulation of advanced artificial intelligence might look like. And in particular, questions around, how might we get cooperation on a large scale, on a national scale and international scale to make sure that people don't build and deploy risky AI systems. And then I also spend a bunch of my time thinking about the alignment problem, continuing work that I was doing at DeepMind, and in particular, trying to understand the problem better and then explain it to people in machine learning and elsewhere so we can build a better understanding of what we actually need to do to try and fix it.
Yeah, so I guess looking over your CV, it seems like you've spent quite a bit of time doing technical ML work, but these days you're at OpenAI, your title involves more of focusing on governance. Are you more doing technical or policy stuff these days, or maybe are you kind of at the interface of both of these things?
Yeah, I'd say I'd split my time between them. I'm not doing a huge amount of coding these days, but I am thinking about alignment questions from a technical perspective. And I think really the key thread going through here is just I've been trying to figure out where the biggest gaps in the field are and how I can fill them. And so originally it felt like that was in the technical domain, but then I realized that there was much less clarity about what the problem actually was and how we understood these high-level concepts than I expected. And so I shifted into focusing on that for a little while. And then it felt like there was some stuff in AI governance that felt not very fleshed out, maybe pre-paradigmatic, and it felt like there was an opportunity for me to contribute there. So I'm really just trying to figure out what's the key missing step in humanity's plan for dealing with advanced AI.
So yeah, one reason among a bunch of others that we're having this conversation right now is that AI is a super hot topic at the moment. Well, I guess mainly because there's been just super impressive and striking results recently with language models and image models and so on that have really gotten the public's attention. On a personal level, how excited and or anxious do you feel about all of this rapid progress that we've seen as someone who's actually working really close to it all?
Yeah, it does feel like the progress over the last couple of years in particular has been very compelling and quite visceral for me just watching what's going on. I think partly because, the demos are so striking, like the images, the like poetry that GPT-3 creates, things like that. And then partly because it's just so hard to see what's coming, right? Like people are really struggling to try and figure out what things can these language models not actually do? Like what benchmarks can we design? What tasks can we give them that are not just going to fall in like a year or maybe a year and a half? And so that feels like the whole field is in a state of suspense in some ways. Like it's just really hard to know what's coming, and it might just often be the things that we totally don't expect, like AI art, for example.
Yeah, I guess there's two things going on here. One is just that the capabilities are ahead of where people forecast them to be, and they're also ahead of where they forecast it to be in a kind of strange direction, that the progress is occurring on the ability to do tasks that people didn't really anticipate would be the first things that AI would be able to do. And so I guess it's just massively blown open our credences or our expectations about what might be possible next, because it seems like we don't have a very good intuitive grasp of which things ML is able to improve at really rapidly and which ones it's not.
Right. And I think I often hear this argument that says something like, oh, look, AI is not going to be dangerous at all. It can't even, load a dishwasher, or it can't even, fold laundry or something like that. And I think that actually it turns out that a lot of really advanced and sophisticated capabilities, including, some kinds of reasoning, like advanced language capabilities, can actually just come, and like coding as well, actually, can come significantly before a bunch of other capabilities that are more closely related to, physical real world tasks. So I do think there's pretty open question as to, what the ordering of all these different tasks are, but we really just can't rule out a bunch of like pretty vital and impressive and dangerous capabilities coming even earlier than, things that seem much more prosaic or much more mundane.
Yeah, it is. I think that this is a long-standing paradox, right? That I think Moravec's paradox, that the things that we think of as being really difficult, AI finds easy, and the things that we think of as really easy, AI often finds really, really difficult, which I suppose means that it could be that loading the dishwasher is kind of the last piece, the last thing that falls into place for AI to kind of be able to compete with, human staff in many different domains. I guess in this conversation, we're going to be focusing quite a lot on the downside risks, because if we can avoid all the downside risks, then hopefully eventually we'll get to harvest all the gains from AI at some point before too long anyway. But let's take a moment to appreciate all the great upside. If things are really well, is there a benefit that you're really looking forward to personally from all of these scientific advances?
So one thing that I'm pretty excited about is it feels like a lot of fields of science have hit a point where it's just really hard for humans to understand what's actually going on. Like on an intuitive level, like protein folding, for example, humans just can't visualize these types of things. Or, some domains of mathematics where it's gotten so abstract and it's at such a high level of complexity that it really feels like we're approaching the limits of what human minds can actually do unaided. And so I'm just pretty excited about having systems that can hold much more in their heads, that can like really, think about, advanced mathematics, for example, in the same way that humans think about like shapes and objects around them in this just like very intuitive sense. And yeah, like the types of progress that we can get from that feel pretty exciting. Just like a broader understanding of more complex systems, like whether that's bodies or economies or minds or societies than we currently have.
Yeah. I suppose we don't know what might result from that. It could be that there's all kinds of amazing and perhaps obvious in retrospect scientific advances that are just kind of strangely blocked to the human brain because of its architecture, because of the particular kind of spatial reasoning that we're good at and the potential spatial reasoning that we're bad at, and kind of, how small our short-term memory is and things like that. And perhaps, I suppose, well, this is also a slightly concerning thing that, that we don't know what advances might come quite rapidly once ML models can kind of do that conceptual reasoning and do that science for themselves.
Yep, that seems exactly right.
But on the other hand, it could be incredible. You mentioned just a minute ago that you're working on ways that governments maybe could regulate the training of really big models. Yeah, why would that be desirable?
Broadly speaking, we don't want a situation in which different actors, whether they're companies or countries, are trying to cut corners in developing increasingly advanced AI systems. And so it feels like we really want some kinds of cooperation here in order to make sure that everyone's, sticking to the same standards and, sharing best practices and like keeping each other informed about the types of, examples of dangerous capabilities that they've seen, or maybe anything that's particularly concerning, and having the ability to sort of slow down when that's actually necessary. And I think, a lot of ideas along these lines have been floating around in the space for a while, but the type of work that my team is trying to do is focusing a little more on making that concrete. Like, suppose we had an agreement between, different countries to apply some kinds of standards to AI development. What sort of enforcement mechanisms could we have? What sort of metrics could we be looking at, and things like that. And a lot of that work actually comes down to a bunch of technical details, like, what types of properties of large models or training setups can you automatically verify? Or what types of secure verification can you do on like the physical chip hardware? These are some of the questions that we're starting to look into now, which I'm pretty excited about more people looking into.
Yeah, I suppose an analogy that comes to mind is with, I suppose this may be an unfortunate analogy, but to nuclear weapons as an example, right, where you've wanted to have all of these governance arrangements in order to prevent something that both like nuclear technology does like has large potential upsides and also large potential downsides, and so you want to have some rules about who can access it and on what terms. So it's quite a bit more challenging in a way because computer chips are just used in so many different things, and probably and their cost is coming down in a way that that nuclear technology is not. Where I suppose the peaceful uses of nuclear technology we've found tend to occur in like quite small, particular isolated places that they're just not that numerous. It's easier to tell what's going on. Do you actually think it's going to be very, very practical to limit people's access to compute in the medium term?
I think if you're focusing on the largest training runs that are done by, the biggest ML research labs or the biggest projects, then I think there's some reasons to be optimistic here, especially when we're looking at the nuclear analogy. I think things have probably just gone significantly better than one might have hoped. I mean, there were a lot of people who were, despairing pretty heavily a few decades, like in the 70s, 60s, 70s, about the future of nuclear regulation and treaties and so on. But it seems like we've somehow muddled our way through. And so it may be the case that, even though there's no, silver bullets for this, we can kind of just get a bunch of agreements on the table and muddle our way through in a roughly analogous way to how we've done in the nuclear case.
Yeah, I guess in as much as the models, like training the most oppressive models that we might be most concerned about just involves enormous amounts of compute. Maybe that has a pretty high visibility, or that, the cost is pretty large. It's kind of hard to do it under the radar. So it does look a bit more like potentially working with, developing either nuclear weapons or developing peaceful nuclear power. It has quite a big footprint.
Yeah, that's right. Like the sort of scales we're talking about are already pretty large for the biggest models, millions of dollars of compute spent training them, and then probably just going to become significantly bigger over time. The other factors are, of course, that there's a bunch of progress in terms of like more efficient training algorithms and, compute advances that are going to lower that threshold for like how easily can you build a model with a given level of capabilities over time. So it feels like there are a bunch of open questions here, but at least the sort of baseline efforts to make sure that people don't use like very large amounts of compute specifically doing dangerous things. It feels like there's some hope there.
Okay, before we dive too deep into specific solutions or anything like that, I think it'd be good to get on the table a bit of a basic grounding of what is the problem that we're worried about here, and why would we think that it's potentially a really important global priority that the kinds of people who listen to this show should care about. You've written that when you started getting involved in the AI safety community, you found the thinking to be quite a bit, perhaps more muddled, maybe a bit less clear than what you had expected going in. I think that among other reasons, has prompted you to spend quite a bit of time writing up the underlying issues and trying to present the core ideas in a crisper and, I suppose, hopefully more accurate way, including, I think, in the AGI Safety from First Principles report, the AGI Safety Fundamentals course, and this more recent one that I think you're still working on called Alignment 201. Is that right?
That's right.
Cool. So let's go through some of these fundamental reasons why we should care about this whole topic in the first place. In my experience, everyone has a slightly different way that they think about the challenge we face, safely developing and eventually at some point deploying advanced AI systems. Yeah, how would you personally describe the overarching issue? So
in the classic paradigms of machine learning, you're training a system on some amount of data on a task, and you get an output, which is, a model that can perform that task. And maybe that task is playing StarCraft, or maybe that task is playing Go, or recognizing images, or things like that. And over time, we're seeing increasingly general systems that can perform tasks that are less and less related to the specific training data they got. So, GPT-2 and GPT-3 were big steps towards more general systems that can transfer experience from, seeing a lot of text on the internet into performing novel tasks. If you prompt them with a task that you just made up, they can often perform it after being given a couple of examples. And so this core premise of generality, that eventually we're going to have systems that can transfer, from performing well on some tasks that they've been trained on to performing well on pretty novel tasks. I think that's the first key idea. And then the question is how are they going to do that, right? What's the mechanism by which you can take a system that hasn't been trained on a task like running a company, being a CEO, or has been trained a very small amount on that and actually starts to perform very well on it? And I think what seems very plausible to me is that the way they're going to do it is by reasoning about the world, having these sophisticated models of the world and trying to figure out what actions are going to lead to which outcomes. So that's the second step, this reasoning about outcomes in the world. And then I think the third key idea is that when you're doing reasoning about outcomes in the world, then the more powerful that reasoning is, the more you want to make sure that the outcomes that it's aimed towards are just very specifically what we want. If you have a system that's mostly just copying the things that it's already seen, or mostly just, mimicking the data that's been given, then, we're not so fussed about specifically how it's doing that, because it's going to stay roughly within the bounds of what we expect. But if you've got a system that's coming up with totally new strategies, that's reasoning its way through, I want to achieve this long-term outcome, so I can take these intermediate steps, accumulate some money, use that money to pay some people to do this task, and just generating pretty novel and unusual plans for performing those tasks, then you want to make sure that the outcome that's actually aiming for is very specifically what we want. Otherwise, those plans might include things like deception, manipulating humans, harming humans, things like that.
Yeah, so I guess the basic idea is that it would be very natural for these models, as they become more and more sophisticated and we try to find ways to make them capable of doing more and more things and more valuable things, that they would start to have this very general reasoning and planning capacity
right.
at the level of humans, and potentially beyond that, more at the level of what whole organizations are capable of, or perhaps beyond the planning and strategizing capability that we presently have at all. And I suppose at the point where a system like this is capable of coming up with thinking of ways of achieving its goals that are quite different than what we might have expected, or quite different than what we might have wanted, then it becomes quite important that we have specified the goal correctly, so that it doesn't end up using means that are very different than what we had intended for it to. Is that kind of one way of putting it?
Yeah, that's right. And then I think the how big of a problem do you think this is depends in large part on how far you think these systems are going to get. How intelligent are they going to be? How far are they going to be able to generalize? What types of tasks are they going to be able to perform to what level? And I think there's just I don't see any particular boundaries on how far these things can go. If we're building systems that consist of neural networks that are, much larger than the human brain, that are using much more compute, that are deployed on very large scales on much more data than any human has ever seen, then it just doesn't really seem like we can be confident at all that the returns to being more intelligent and coming up with better plans tail off at any given point.
Yeah. So the AI that people have been most likely to play with and taken an interest in this year are these image models and these text models where you throw in some text and you get an image or some text back. But there are systems that are more like this planning, strategizing thing, right? Of course, there's the famous ones that play chess or Go and so on. But perhaps a bit more like real life planning are the ones that play computer games like StarCraft 2 or Dota 2 that involve potentially like quite long term planning across a very wide, like a very broad space of possible approaches that one could take to playing this game. And they're getting very good at that style of strategy and planning, which is beginning is a step in the direction of thinking about how you might operate in the real world.
So I'd actually say that I feel pretty uncertain about whether systems that play esports like Dota or StarCraft are actually doing planning in a meaningful sense.
Okay.
Just because they've been trained on so much data, it seems pretty plausible to me that they've just learned a bunch of heuristics and like the sort of high level pattern recognition that says, when the enemy is coming towards my base, like, go left to avoid them or something like that. So I think this is something that people should really look into and try and figure out to what extent are these systems actually internally making plans like inside the neural network as they process information. But I don't really have a strong opinion on whether that's happening now or not. Some examples that are a bit clearer. So I think the Go and chess engines that were built by DeepMind, like AlphaZero, they clearly do some type of planning, but in a very narrow domain. And so it's pretty hard to say whether the type of planning that they do specifically, which is like searching through a whole bunch of possible moves in order to find desirable board states, whether that is going to actually transfer to more sophisticated systems. But I also think that language models are actually a pretty good example to look at right now, because if you start to ask language models how to perform some high level task, like if you ask GPT-3 to give you a plan to, become really good at a certain skill or to achieve a certain outcome, it often gives you plans that are pretty sensible. And then I think there is a clear difference between being able to generate a plan versus being able to act on that plan. But it still seems like being able to generate the plan is much closer to being able to act on the plan than we might have expected a few years ago. I think I personally was pretty surprised when I started asking GPT-3 to generate plans for things like, if you were an AI in this situation, what would you do? And then it could just come up with a whole bunch of possible strategies that an AI might take in order to achieve certain goals. And so I don't see what the barrier is that prevents them from jumping from here's what an AI should do in a given situation to, once we start training it in more real world context, once we take versions of these language models and give them access to computers or things like that, then actually being able to carry out plans over longer and longer time horizons. Like it does seem like a gradual process, but we seem like surprisingly far along the route of systems that are actually able to generate compelling plans.
Right. Yeah, I didn't know that. At a high level, are there any kind of considerations or like what's one of the most important arguments, I suppose, that makes you think that there's a real worry here, that there's an issue that has to be addressed rather than this being the kind of thing that is just going to be solved in the natural course of events, or perhaps we're just misunderstanding the situation and there's really nothing to be worried about in the first place?
I think one argument that feels pretty compelling to me is just we really have no idea what's going on inside the systems that we're training. So you can get a system that will write you dozens of lines of code that implements a certain function that leads to certain outcomes on the screen, and we just can't figure out, like we have no way of knowing what it's doing internally that leads it to produce that output. Like why did it choose to implement the function this way instead of that way? Why did it decide to, actually follow our instructions as opposed to doing something quite different? Like we just don't know mechanistically what's happening there. And so it feels to me like if we were on course to solving this in the normal run of things, then we would have a better understanding of what's going on inside our systems. But as it is, like without that core ability, it feels hard to rule out or to be confident that we're going to be able to address these things as they come up, because just like
it's a black box.
As these systems get more intelligent, anything could be going on. And there has been some progress towards this, but it feels, still very far away, or like the progress on this is not clearly advancing faster than the capabilities are advancing.
I suppose this is the first really complicated machine that we've ever produced where we don't know how it works. We know how it learns, but we don't know what that learning leads it to do internally with the information, or at least we don't know it very well.
Right. And, in some sense, raising a child is like this, but we have, many more guarantees and much more information about what children look like how they learn and what sort of, inbuilt biases they have, such that they're going to mostly grow up to be like moral, like law-abiding people. So maybe a better analogy is just raising an alien and just like not having any idea how it's thinking or when it's trying to reason about your reactions to it or anything like that. And, right now, I don't think we're seeing very clear examples of deception or manipulation or models that are like aware of the context of their behavior. But again, this seems like something where there doesn't seem to be any clear barrier standing between us and building systems that have those properties.
Yeah, even with humans, not all of them turn out to be quite that benevolent.
Absolutely.
Yeah, what's another important reason you think advances in AI may not necessarily go super well without a conscious effort to reduce the risks?
I think that a lot of other problems that we've faced as a species have been kind of on human timeframes. So you just have a relatively long time to react and a relatively long time to build consensus. And, even if you have a few smaller incidents, then things don't accelerate out of control. I think the closest thing we've seen to, real exponential progress that like people have needed to wrap their heads around on a societal level has been COVID, where, people just had a lot of difficulty grasping how rapidly the virus could ramp up and how rapidly people needed to respond in order to have like meaningful precautions. And so in AI, it feels like it's not just, one system that's like developing exponentially. It's like you've got this whole underlying trend of things getting more and more powerful. And so we should expect that people are just going to underestimate what's happening and the scale and scope of what's happening consistently, just because our brains are not built for visualizing the actual effects of fast technological progress or anything near exponential growth in terms of like the effects on the world.
Yeah, for me, maybe the thing that makes me worry the most is the analogy to humans, where humans got to be somewhat smarter than, or at least more generally capable than the species around them. And then over time, by accumulating knowledge between generations and increasing the number of brains and the number of humans that are out there, we kind of took over the show and now get to dominate what happens. And then you think, well, in future, you could have AIs that similarly become more generally capable than humans are and potentially can operate faster. And then, of course, they can become extremely numerous because we can just produce more chips on which they can run. And so by analogy, one might think, well, perhaps most of the decision-making and most of the influence over the future will be passed over to these potentially even more numerous and even more capable beings. So we better make sure that we've raised them right. Does that argument kind of stand out in your head as well?
Yeah, I think this is a pretty strong argument for, taking the problem seriously, just on a very basic level, just like, oh, this is a thing that could happen and like could happen on relatively fast timescales, in the same way that humans ended up basically in charge of the world on timescales that were very rapid in evolutionary terms. I think I've placed a little bit less weight on this argument than I used to, just because it feels like now that we have more details of understanding like deep learning, neural networks, the types of systems that we're actually building, we can start to zoom in a bit more. I think like this argument is most compelling when you just have like relatively little idea of the types of AIs that we're going to build. And the more detail we have there, the more we can start to make like more specific arguments, I guess. So I started doing my PhD on this like broad analogy of like thinking about the link between human intelligence and artificial intelligence. And then one of the reasons that I moved away from this was because I thought that we could just zoom in more and kind of like get more confidence by actually thinking about the cutting edge systems that we have today.
Yeah, that makes sense. how much does it influence you, the fact that there's this kind of debate back and forth where people will try to suggest a way that you, like some sort of instruction that you might be able to give to ML systems and say, well, if we gave them this kind of instruction, then it seems like it would be safe. And then people try to think, well, how could that be perversely interpreted? And how could that lead to undesired behaviors? And then they'll come back with some objection saying, no, this permits, or it even might encourage, power seeking or deceptive behavior. And then people will try to patch it. And then people will object again that still doesn't work. But the fact that people haven't been able to propose kind of an objective that you could give ML systems that seems robustly safe troubles me. Does that also trouble you?
Yeah, I think the thing that particularly worries me here is that it feels like people have pretty different standards for what counts as evidence about a solution to the problem compared with what counts as evidence for the problem existing in the first place. So, there are a lot of people who say, well, this is quite speculative, like we can't really know anything about future systems, so we may as well just wait and see. But then often those people will also say, and look, here's a potential solution that could work, and just throw out a few haphazard ideas. I think if we're really going to take seriously uncertainty about the future, which I think we should, it's just very hard to predict this stuff, then I just have never seen the sort of proposal that gets anywhere near the level of rigor and carefulness that it should motivate us to say, well, we should be happy with this. Let's not actually work on the problem anymore. Let's focus on other things. It seems like we're just absolutely nowhere near having solutions that we can be sufficiently confident in to kind of dismiss the problem.
Yeah. Is there any other kind of common response or kind of common skeptical response that you get to these concerns that you think is misguided?
A lot of people talk about anthropomorphism as in, it seems like people who are worried about these problems are expecting AIs to be more similar to humans than they actually will be. And, I think this is an important and valuable intuition to have. Anthropomorphism is very common, and we should definitely watch out for it. I think the idea of systems pursuing goals and trying to reason about how to achieve those goals, though, is just fundamentally not an anthropomorphic concept. It's just a claim about how intelligent systems can achieve outcomes in the world. And so as long as we're assuming that we're going to have systems that can achieve these long-term, large-scale outcomes in the world, that can, actually run companies, for example, or actually make decisions about what sort of plans they want to implement, then I think I have a hard time seeing what other strategies and mechanisms they could use apart from some kind of planning and reasoning about their models of the world. So that, it is important to watch out for anthropomorphism, but in this particular case, it feels hard to say what the alternative is.
Yeah, I suppose, there's some behaviors that you might think are extremely fundamental. And yes, ML systems in future might share them with humans, but that's just because that's the way you get things done. So, for example, trying to anticipate how things would be different if you behave differently, that's something humans do. It's probably something that any agent that's trying to influence the future course of events is probably going to do as well.
Right.
But I'm surprised that people kind of make that argument, because in my mind, the thing that I'm more worried about is that the AIs are going to operate in an extremely inhuman way. If they were going to behave like people, then I would be less concerned, because I kind of know how people behave, and there's only so bad it gets, and there's only so strange it gets. But kind of the problem is that because these are alien minds in a way, really all bets are off. It could behave in extremely unpredictable and strange ways that we'll never expect another person to.
Right. And I think, people might say, well, we don't even need to think of these as alien minds. We can think of them as just software or something. Just it does what we try to build it to do, because that's what software does, and we're going to engineer it in the same way as we do current software, which is a lot of checks, a lot of tests, and things like that. And I think fundamentally that's not taking seriously enough the idea of generalization and transfer to new tasks, the idea that you can actually have systems that are not just doing one specific thing that you design them to do, but actually just can think about the world as a whole, that understand the world as a whole, and can apply that knowledge in many different domains. So I think that's the sort of core premise that you need to take seriously in order to switch from thinking of AIs as just normal products that we're building to actually, other minds, if you will, and other minds that may be trying to achieve things.
Okay. Yeah, we'll come back to discussing the nature of the problem later on, and we're actually going to talk about a paper you wrote called "The Alignment Problem from a Deep Learning Perspective," which talks about some of these issues in a slightly more technical and precise way. But for now, yeah, let's come back and focus on getting up to speed on what's been going on in the AI world over the last 6 months or year. As we mentioned in the intro, you work at OpenAI these days, because a lot of listeners will have heard of OpenAI because it's made a bit of a splash with its various language models, and this year its image model, DALL-E 2. For those who aren't familiar, though, can you give us a refresher on what OpenAI is trying to accomplish?
Broadly speaking, OpenAI's goal as an organization is to make sure that the development and deployment of advanced AI systems goes well. And what specifically that looks like has changed a bit over time, but I think some of the key things that people at OpenAI are thinking about are how to make sure that we build systems that are aligned with human preferences, how to ensure that those systems are governed well, and then make sure that the benefits are distributed widely to people across the world. And then, what that looks like on a day-to-day basis is a bunch of people just like doing research on cutting-edge machine learning systems. And I think in particular from a very empirically focused perspective. So I think OpenAI, as compared with most other machine learning labs, is just much more focused on actually building systems and then seeing what happens rather than doing much more abstract theoretical work.
Yeah. Okay, so it's a bit more of a learning by doing mentality. Is that it?
Right.
What are the different kind of strands of safety-related work that people do having built these models? Are there different kind of schools of thought or different approaches that people are adopting?
So the main thing that the people on the alignment team at OpenAI are doing is applying reinforcement learning from human feedback. That is like getting a bunch of humans to evaluate the behavior of our models and score their outputs and then feeding that back into the system to try and make sure they behave in more desirable ways. And that's led to a few different products and releases like the Instruct GPT models, which are fine-tuned to be more obedient than the original base models. And then people are working on trying to leverage this to perform tasks that humans have a lot of difficulty supervising. So, for example, an AI system that is being used to summarize a whole book. That might be very difficult for a human to evaluate because it's just hard to like read the whole book. It takes a long time and then check whether the summary is correct. So some of the types of work that people at OpenAI are doing involves breaking tasks down so that they can be more easily evaluated by humans. And then I think this is just going to become increasingly important as the tasks that AIs perform become more and more complex. And then after the systems have been built, there's a whole branch of the organization that focuses on what to do with them. So this is the broader policy research team, of which the governance team is a part. And the focuses of the policy research team include things like how should we like release these models to the public, or when should and if we should release the models to the public. And so OpenAI has focused on releasing models via an API that allows us to monitor what people are doing with them and like figure out how the capabilities of those models are actually advancing over time and what sort of things we want to be on the lookout for.
Okay. So it's really, I suppose it's very applied stuff where you've got particular models and then you're trying to, I guess improve them with feedback and look at the results and see where they're going wrong and try and improve it. And then I guess on the delivery side, then you've got to think about all of these really practical issues about which models are safe to put out, which ones aren't, and then can you release them in a way that doesn't fully release them, that allows people to use them, but within particular reasonable bounds.
Right.
Yeah, why did you decide to work at OpenAI rather than somewhere else? There's been quite a proliferation of different groups trying to make AI safe lately.
Yeah, I think I chose to work at OpenAI because it felt like a bunch of the people there were pretty excited about the work I wanted to do, which is this, high-level thinking about how we can affect the development and deployment of AI, including governance and including high-level alignment thinking. So yeah, it felt like there was buy-in from people at OpenAI to like having more people understanding these and then taking actions accordingly. Partly that's because OpenAI is a pretty non-credentialist organization. So, they encouraged me to drop out of my PhD because they thought that it was just more important for me to start doing the work immediately. And in hindsight, I think that makes a lot of sense. And it's increasingly common that like larger research organizations are less focused on people having PhDs. And I think OpenAI has been leading the trend in that regard. So those are a couple of the key reasons. And of course, there are just like a bunch of great people there who I'm like very excited to work with. In particular, the team I'm currently on, which is headed by Jade Leung and has a few other great people who I work with every day.
Yeah. The biggest worry I hear about OpenAI strategically is that, so one framing of these issues is that we have something of a race between improvements in what AI is capable of doing in its ability to learn quickly and efficiently from data and its ability to generalize and plan and all that stuff that we've been talking about earlier. And then our understanding of how we can pair those systems with, or how we can organize those systems so that they act in ways that are predictable and safe and aligned with our intentions and so on. And I guess a worry might be that all of the research that OpenAI is doing in AI is really quite impressive, and maybe it's advancing the first of those things. It's advancing the generalizability, and it's advancing the efficiency and so on in a way that leaves less time for the second side of things that you're potentially working on. Yeah, how does OpenAI think about that issue? I guess sometimes it's called a differential technological development.
Yeah, so I think I already mentioned that OpenAI is very sort of empirically minded organization that's like very focused on like seeing what evidence we can collect from cutting edge models and then updating accordingly. So I think that like OpenAI's position on this has developed over time as like we get increasing amounts of evidence that actually, you know, we're pretty uncertain what's going on with these models, and there's like increasing reasons for caution. So yeah, this is something that people are pretty actively thinking about, just how to ensure that we don't get into worrying races or like cases where people are cutting corners. And overall, I think that, yeah, just in terms of investing in alignment in particular and also governance, I think that's really a case where we want as many great people as we can get. So that's like one of the key focuses, is just like bringing in people who can in fact help figure out what the best strategies are. And that's a significant part of what my job is.
Would you personally like to see, ML research as a field progress AI capabilities, and get closer to potentially general AI? Would you like that to happen sooner and faster, or slower?
I think the line between alignment research and capabilities research is in fact a little thinner and blurrier than people used to think. So, there's a lot of work on interpretability, for example, that could, in theory, eventually be used to design better architectures or like more sophisticated training algorithms or things like that. And in general, I'm mostly interested in the field of ML being more of a scientific discipline rather than just sort of, like Facebook's motto, move fast and break things. Like I prefer, I think these are kind of like two different approaches to thinking about machine learning. And I prefer we have this like careful scientific style understanding of what we're trying to do, as opposed to moving fast and breaking things.
I see. So it's not just about let's just make new stuff that kind of seems to work. It's you more want to have a mentality that we want to deeply understand what is going on here. We want to actually understand the phenomenon.
Right.
OpenAI, I guess, has its kind of high-level strategy or high-level description of what it sees as a potential path to making AI become both more powerful but have it go well. If that strategy doesn't work out, what do you think is the most likely reason for it to fail or go awry?
Probably that the underlying bet that OpenAI is often making, which is that, an empirical understanding of the bigger systems is like the best way to make progress. Like we could just be in a world where that's not actually the case, and we need like more foundational theoretical research, for example, or like more time just spent trying to understand the models we have, for example. And, so I tend to think of OpenAI's alignment research as like part of a wider portfolio of bets that the alignment community is making, where, OpenAI is focused particularly on the case where a bunch of like very empirical work is going to be the best bet. And then other groups are focused a bit more on, more theoretical work and like, trying to do more prediction in advance of what these sophisticated systems are going to look like, rather than focusing on the things which are currently at the cutting edge. And yeah, so that's just like one way in which different people are making different bets. And I feel uncertain about which category of bets is going to end up being the right way to go.
What's an argument that stands out to you on the kind of question of, should you as an individual work on the empirical side of things, or perhaps more the theoretical or conceptual side of things? Or is that just an incredibly difficult one?
I tend to think that people should go with their comparative advantage a lot of the time, in particular, what interests them the most and what they really enjoy doing, what like can they imagine getting really obsessed with. So by default, I think that, starting off by actually just like staring at these systems a lot, like trying to getting as hands-on as possible just seems like a robustly good strategy. And then if from there you start noticing ways in which like, hey, there's this like interesting phenomenon that I want to try and understand on a deeper level, or like I should branch out into like doing a bit less like building these systems and a little bit more, of a different type of research, then that's in some ways the strategy that I did myself, where I started off as an engineer and then realized that there were a whole bunch of higher level questions that I wanted to have answered and that nobody else was really trying to answer. So I think I recommend that for most people.
Okay, yeah. Pushing on from OpenAI specifically, I was hoping we could maybe go through some background empirical information that I think, that I think I understand. Maybe you'll be able to correct some of it, but that I think kind of maybe informs some of my worries and some of my predictions about how things might go. First one was, do we have a rough idea when it will be affordable to run AIs with the same total computational ability as a human brain? And is that the right way to think about it?
So I think the thing that's worth distinguishing here is between running an AI that uses the same amount of compute as a human brain versus training that AI in the first place. So when we're talking about these large neural networks, much more compute is spent on training the system in the first place than in actually running it. And so according to a report by Joe Calfsmith from Open Philanthropy, we actually already do have enough compute to run the equivalent of a human brain. It's just that in order to get a neural network that's the size of a human brain to do useful things, you need to do a bunch more training, which is going to take a much more compute. And that feels like a much more difficult thing to estimate because, how are we going to train the system on what data? These are all uncertain variables. But the best estimate we have from that is by Ajaya Kotra, also from OpenPhil. And she thinks that it's plausible within this decade and then likely within the decades after that we can train systems that are as large or do as much computation as the human brain.
Okay, so there's two quite different stages, I guess. There's the training stage, which involves a huge amount of computation. And then there's the, like, having trained the model, then applying it, which involves a whole lot less. I suppose you can think about at the training stage, is the training process using as much compute as a human brain has available is one question. I suppose you could also think, well, a human brain is trained over a very long period of time. So maybe we should ask the question, during the training process, is as many computations done as a human does over their entire lifetime? Would that be a more sensible question to ask? Can you deconfuse me?
I think all of these things are sensible things to ask, and it's pretty unclear which of them is the most relevant. So in the original report by Ajaya, she just used a bunch of these different possibilities as anchors for the estimates. So she just estimated, how much compute would we need if it turns out the closest analogy is to, the amount of compute used by a human brain over a single lifetime versus a bunch of different other possibilities. So it's hard to say what the most analogous setup is. I think, because evolution did a lot of work in getting human brains to the point where we can learn really efficiently, it feels like you're very likely going to need much more experience and much more training than an individual human does throughout their lifetime. But whether that's, a couple of orders of magnitude or like many orders of magnitude is like really hard to know. Probably, it starts off being many orders of magnitude, and then as algorithms get better, it starts dropping until you get to pretty comparable, efficiency as the human brain would be my best guess.
Okay. So one answer would be, well, we already do have computers that can do as much compute as the human brain. And then another answer, well, depending on how you look at it, you could say, well, maybe this decade, or if not, at least in decades to come, if kind of current trends persist. So there's this big ratio between the amount of computation required to train a model and then how much there is to apply it, which I guess means by the time you have enough computation around to train a system that looks at all like a human being, by the time you've done that, then with the compute that you used for that, you'd be able to run this system, many instantiations of it. Do you have a sense of how many people you could run one by the time you've trained one of them?
So this is a slightly tricky question to answer because it depends on, exactly how your training setup works. Like if you use a very small amount of compute for a very long time, that's going to be different than if you used, a lot of compute for a short time when training it. I think a reasonable ballpark figure is that you can run thousands of copies of a given model using the same amount of compute that you used to train it. But probably a better way of thinking about it is just in terms of cost. So, training a cutting edge language model, numbers around like 1 million, 10 million seem pretty reasonable for how much it costs to actually run all of that training. And then the cost of using that model to actually do a task like writing an essay or solving a problem for you is more like 1 cent. So that's like a pretty massive disparity between, what it takes to actually train the model versus what it takes to run it. And in some cases, the disparity can be smaller. So in systems like AlphaZero, for example, you can just use as much computation as you want when running it, because that's an architecture that's actually very scalable at runtime. You can just like keep using more and more of it to like search through different possible games. But for our current cutting edge systems like these large language models, it's a fairly fixed ratio, which is something like $1 million or $10 million for training to a couple of cents for doing standard tasks.
And I suppose with images, it might be similar: $10 million to train it, and then a cent per image that you output.
Yep.
So it's a pretty big ratio. Although I guess I'm not exactly sure. I suppose producing one image might turn out to not be very much in the scheme of things in terms of one's reasoning capacity. So actually running an actor that was doing all sorts of stuff might involve producing the equivalent of very large numbers of images, and so it might actually cost a decent amount of compute and electricity and so on.
Right.
What's something we've learned, or think that we might possibly have learned from recent advances in AI capabilities?
So I've already alluded a little bit to how the unpredictability of capability advances and how, things like reasoning, strategic thinking, and so on might just come much earlier than we expect. I think another thing that has felt pretty important is that we don't really know what the capabilities of our systems are directly after we've built them anymore. So once you train a large language model or a large image model, it may be the case that there are all sorts of things that you can get it to do given the right input, the right prompt, the right setup, that we just haven't figured out yet because they're like emergent properties of what the model has learned during training. So probably the best example of this is that people figured out that if you prompt the model to think through step by step in its reasoning, it's able to, these are like large language models, they can answer significantly more difficult questions than they could if you just give them the question by itself, right? So, and this makes sense because this is what humans do, right? If you tell somebody to answer a problem by working through like maybe an arithmetic problem, calculate all the intermediate values, they're probably much more likely to get it correct than if you just say, and you have to give me the final answer directly. But this is just something that it took ages for people to figure out, because this is, this was applicable to GPT-3 and I think also to some extent, to a lesser extent to GPT-2, but papers about this were only coming out like I think last year. So these are the types of things where actually just figuring out what the models can even do is a pretty difficult task and probably just going to get increasingly difficult.
Yeah, that's really fascinating that we might just not, I suppose, because the exploration space of prompts that you can give to these models is so vast. It's incredibly open-ended. It's just any kind of text. That it could be many, many years in principle until someone tries out something and then discovers, oh, well, if you phrase the question this way, if you give it this kind of lead in, then you get this different result than what you're getting otherwise. And so in a sense that the model might be much more capable than we'd realized previously. Can that just keep on going and going?
I think so. And I think it's probably going to get worse because we can think of this as an alignment problem. So in some sense, alignment problems are when your model can do the thing that you want it to do and it just doesn't do that, as opposed to sort of capabilities problems where it can't do the thing that you want it to do. And so in this case, this is like a less deliberate or let's say malicious alignment problem because, we're trying to get it to do a task and it's just like, it's not that there's any like deliberate deception going on. It's just that we haven't put in the input in the right way. But you can imagine in future systems, we're trying to get them to do a task and they might just make a deliberate choice not to do that task. And that's something that we would have a lot of trouble distinguishing from the model not being capable of doing the task. So I think over time, the difference, like trying to figure out what capabilities our model has, might become something of an adversarial problem where you actually need to reason about like what the model's intentions are, like what it's trying to do, and like what information it wants you to have, basically.
Right. I hadn't noticed how analogous this is to the kind of alignment problem, or giving values or communicating instructions problem in general. Because I suppose you're saying it's definitely an alignment problem. If there was a thing that you could have said that would have communicated better what output you wanted to the model, but then you said something that wasn't quite right, it was phrased the wrong way, and so you got a result that you didn't want. But how does that connect to the adversarial issue, or the idea of the model trying to kind of second guess what you want and maybe giving you something that you don't, even if it knows better?
Right. So you can imagine that if we're thinking about systems that have learned some kind of long-term goal, then it seems plausible that there are some ways it could demonstrate capabilities that would be more or less conducive to achieving that long-term goal. As a simple example, if you have a model that for a lot of long-term goals, just like having human trust is just useful. And so a model might not want to demonstrate a capability like deceive humans, or might not want to demonstrate a capability like being able to manipulate humans very easily. And, I think this is like not really a big problem over the next couple of years, but like over time, I expect it to become a bigger and bigger problem that, models are going to understand that we're asking them to try something and just not want to do it, basically.
Yeah. Another thing that I've heard some people speculate that we might be learning from these language models, for example, is that, we might be learning something about how humans operate. Because these language models are kind of predictive models where you've got some text before and then it's trying to predict the next word. And it seems like using that method, you can at least reasonably often produce surprisingly reasonable speech and perhaps, surprisingly reasonable articles and chat and so on. Now, some people would say, okay, so this looks like what people are doing, but it isn't what they're doing. We actually have all of these ideas in our minds, and then we put them together in a coherent way because we deeply understand the actual underlying ideas and what we're trying to communicate. Whereas this thing is just chucking like word after word after word in a way that produces a simulation of what a person is like. But I suppose when people aren't thinking that deeply, maybe we operate this way as well. Maybe I'm producing speech extemporaneously now, but my brain kind of can do a lot of the work automatically because it just knows what words are likely to come after other words. Do you have any view on, are these language models doing something very different than what humans do? Or is it, are we perhaps learning that the humans use text prediction as a way of producing speech themselves to some degree?
I think that's a great example, actually, where, like a lot of the time, human behavior is pretty automatic and instinctive, including things like speech, where, as you say, like the words that are coming out of my mouth right now are not really planned in advance by me. I'm just sort of like nudging myself towards producing the types of sentences that I intend. And so I think, if we think about like Kahneman's system 1, system 2 distinction, like that, I think that's actually not a bad way of thinking about our current language models, that they actually do most of the things that human system 1 can do, which is, instinctive, quick judgments of things. And then so far, at least, they're a little bit further away from the sort of metacognition and reflection and noticing when you're going down a blind alley or you've lost the thread of conversation. But over time, I think that's going to change. Maybe another way of thinking about them is, it seems hard to find a task that a human can do in like 1 second or 3 seconds that our language models can't currently do. It's easier to find tasks that humans can do in like 1 minute or 5 minutes that the models can't do. But like, I expect that number to go up and up over time, that the models are going to be able to match humans given increasingly long time periods to think about the task until eventually they can just beat humans full stop, no matter how much time you give those humans.
So is the idea there that, if you only give a human 1 second to just blurt out something in reaction to something else, then it has to operate on this very system 1 or this very instinctive thing where it's just got to string a sentence together and it doesn't really get to reflect on it. And the language models can do that. They can blurt something out. But maybe the thing that they're not so good at is what humans would do, which is maybe look at the sentence that is about to come out of their mouth and then see that that's actually not what they want to communicate, and then edit it and make it make a whole lot more sense conceptually.
Right. And sometimes you even see language models making the same types of mistakes that humans make. So as an example, if you ask it for a biography of somebody, sometimes they'll give you a description of their career and achievements that's not quite right, but kind of in the right direction. Like maybe they'll say that the person like went to Oxford when actually that person went to Cambridge or something like that, where it's like, it clearly remembers something about that person, but it's just like, hasn't like memorized the detail. It's more like it's learned some kind of like broader association. Maybe it'll say that they studied like biology when actually they studied chemistry, but it won't say that they studied, like film studies when they actually studied chemistry. So it seems like there's these kind of mistakes where it's not actually recalling the precise details, but kind of remembering the broad outline of the thing and then just blurting that out, which is what humans often do.
Right. That makes me kind of wonder, is anyone out there spending, most of their day just playing with these models for very long periods of time in order to develop possibly a much better intuition for how these models think, in a sense? I suppose becoming, I don't know, the language model whisperer a bit of the way that people who spend all of their time with horses end up having a deeper understanding of how horses think and what's going on with them at any given point in time.
It's a little hard to track the people doing this. I'm sure there are some. I only know a handful of people who are doing this myself. Some of them as part of red teaming efforts for like trying to figure out what the capabilities and potential risks of our current biggest models are. There are two people at Conjecture, which is a new alignment research organization that are focusing on this. And some of their work is quite interesting. I think the difficulty here is in navigating the tension between trying to really understand a given model very deeply versus the fact that a lot of the things that work for one particular model are going to be less relevant to future models. So a lot of the ways that people tried to cajole or prompt GPT-2 into doing the things they wanted were just like totally unnecessary for GPT-3 just because it understood their intentions better and it understood their instructions better. And so a lot of that knowledge became very quickly outdated. And it feels quite tricky to figure out how to extract generalizable principles from studying our current best models when they're getting better so quickly.
Yeah, that makes sense. What are some bottlenecks to thinking and learning that human beings face, but which these future ML models won't have to confront?
I think the biggest one is just that we don't get much chance to experience the world. We just don't get that much input data, and because our lives are so short and we die so quickly. So there's actually a bunch of work on scaling laws for large language models, which basically say if you have a certain amount of compute to spend, like should you spend it on making the model bigger or should you spend it on training it for longer on more data? Like what's the optimal way to make that trade-off? And it turns out that from this perspective, if you had as much compute as the human brain uses throughout a human lifetime, then the optimal way to spend that is not having a network the size of the human brain. It's actually having a significantly smaller network and training it on much more data. So like intuitively speaking, at least, human brains are solving this trade-off in a different way from how we are doing it in machine learning, where in machine learning, we're just taking relatively smaller networks and just training them on way more data than a human ever sees in order to get a certain level of capabilities.
I see. Okay, so hold on. So the notion here is you've got a particular amount of compute, and there's two different ways you could spend it. One would be to have tons of parameters in your model. So I guess this is the equivalent of having really lots of neurons and lots of connections between them.
Yep.
So you got tons of parameters. This is equivalent to like brain size. But another way you could use the compute is instead of having lots and lots of parameters that you're constantly estimating and adjusting, instead have a smaller brain in a sense, but train it for longer, but have it read way more stuff, have it look at way more images.
Right.
And you're saying humans are off on this crazy extreme where our brains are massive, so many parameters, so many connections between all the neurons, but we only live for so little time. We read so little, we hear so little speech relative to what is possible, and we'll do better if somehow nature could have shrunk our brains, but then got us to spend twice as long in school, in a sense. I guess problem with that might be that you would, I suppose there's all kinds of problems of maybe getting beings to live quite that long, but you might also get killed while you're in your stupid early infant phase for so long.
Exactly. So humans faced all these trade-offs from the environment, which probably neural networks are just not going to face. And so by the time we're training neural networks that are as large as the human brain, we should be expecting that they won't have as much experience as humans do, but they're actually just going to be training on a huge amount more experience compared with humans. So that's one like way in which humans are systematically disadvantaged. We just like haven't been built to absorb the huge amounts of information that are being generated by the internet or videos, YouTube, Wikipedia across the entire world. And that's closely related to the idea of AIs being copyable, right? So like if you have a neural network that's trained on one piece of data, you can then make many copies of that network and deploy it in all sorts of situations. And then you can feed back the experience that it gets from all those situations into the base model. So, effectively, you can have a system that's learning from a very wide array of data and then taking that knowledge and applying it to a very wide range of new situations. So these are all ways in which, I think in the sort of short term, humans are disadvantaged just by virtue of the fact that we're running on biological brains in physical bodies rather than virtual brains in the cloud.
Right.
And then in the longer term, I think the key thing here is just what algorithmic improvements can you make? How much can you scale these things up? Because, over the last decade or two, we've seen, pretty dramatic increases in the sizes of neural networks that we've been using. And the algorithms that we're using have also been getting significantly more efficient. And so we can just think about artificial agents investing in doing more machine learning research and improving themselves in a way that humans just simply can't match because our brain sizes, our brain algorithms and so on are pretty hard coded. There's not really that much we can do to change this. So in the long term, it seems like these factors really should lead us to expect AIs to dramatically outstrip human capabilities.
Yeah. Okay. So they don't die, so they can just keep accumulating knowledge forever, and as more stuff comes out on the internet, they don't have to throw out the old stuff. They just read the new stuff and add it in. I guess as compute gets cheaper, you can just throw more compute at it, whereas the human brain is kind of stuck at its particular clocking speed.
Right.
It's not getting any faster. It's not getting any bigger. I suppose. Oh yeah, and also we can keep reprogramming these things, making the algorithms more efficient. Humans are just kind of stuck with the software that we have, for better or worse. One other thing I'd heard that I'm not sure what the implication is, but don't signals in the human brain, just because of limitations in kind of the engineering of neurons and synapses and so on, they tend to move pretty slowly through space, whereas like much less than the speed of electrons moving down a wire. So in a sense, our signal propagation is quite gradual and our reaction times are really slow compared to what computers can manage. Is that right?
That's right. But I think probably this effect is a little overrated as a factor for overall intelligence differences between AIs and humans, just because it does take quite a long time to run a very large neural network. So if our neural networks just keep getting bigger at a significant pace, then it may be the case that for quite a while, most cutting edge neural networks are actually going to take a pretty long time to go from the inputs to the outputs, just because you're going to have to pass it through so many different neurons.
Stages, so to speak.
Yeah, exactly. So, I do expect that in the longer term, there's going to be a significant advantage for neural networks in terms of like thinking time compared with the human brain, but it's not actually clear how big that advantage is now or in the foreseeable future, just because, it's just really hard to run a neural network with hundreds of billions of parameters on the types of chips that we have now or are going to have in the coming years.
Yeah. So, I mean, all of this kind of raises the question, why aren't computers much better than us at everything already? I suppose you're saying that the thing that the human brain is exceptional in is just it has tons of parameters, which in this case corresponds to lots of neurons, lots of connections between them. Like computers haven't been able to match us with that. And I suppose presumably we also suspect that the algorithmic efficiency is has been quite a bit worse, although that's improving over time.
Right. I wouldn't want to say that the number of parameters is like the be all and end all of how efficient your neural network is. Like I think, we've had some pretty strong results from scaling up neural networks and they've just gotten much better. And so we should expect that trend to continue. I'm not really seeing it stopping anytime soon. But at the same time, how to anchor that compared with a human baseline feels like a very difficult question. Like, should we think of neural networks as being more efficient than the human brain in terms of using the parameters that they have? Is it like less efficient than the human brain per biological neuron versus artificial neuron? Is it like a couple of orders of magnitude less efficient? That feels very uncertain to me. And so the main thing I want to say is just like, as we approach the point where we're training networks that are within a couple of orders of magnitude of the human brain, it feels like, we shouldn't be ruling a bunch of things out. It may be the case that they're, significantly less efficient than the human brain in terms of like converting number of parameters and number of neurons into actual effective intelligence. But it seems like a pretty strong claim to say, oh yeah, they're, many orders of magnitude away in terms of how efficiently they can scale.
Yeah. What's a common misconception you run into about how ML models work or how they get deployed that it might be helpful to clarify for people?
I think the most common and important misconception has to do with the way that the training setup relates to the model that's actually produced. So, for example, large language models, we train them by getting them to predict the next word on a very wide variety of text. And so some people say, well, look, the only thing that they're like trying to do is to predict the next word. Like, it's meaningless to talk about the model like trying to achieve things or like trying to produce answers with certain properties because like it's only been trained to predict the next word. And I think the important point here is that like the process of training the model in a certain way may then lead the model to actually itself have properties that can't just be described as predicting the next word. So it may be the case that the way that the model predicts the next word is by doing some kind of internal planning process, or it may be the case that the way it predicts the next word is by reasoning a bunch about how would a human respond in this situation. I'm not saying our current models do, but that's the sort of thing that I don't think we can currently rule out. And in the future, as we get more sophisticated models, the link between the explicit thing that we're training them to do, which in this case is predict next word or the next frame of a video or things like that, and the internal algorithms that they actually learn for doing that is going to be less and less obvious.
Yeah, okay. So the idea here is, let's say that I was set the task of predicting the next word that you're going to say. It seems like one way that I could do that is maybe I should go away and study a whole lot of ML. Maybe I need to understand all of the things that you're talking about.
Right.
And then I'll be able to predict what you're likely to say next. And then someone could come back and say, Rob, you don't understand any of this stuff. You're just trying to predict the next word that Richard's saying. And I'm like, well, these things aren't mutually exclusive. Maybe I'm predicting what you're saying by understanding it. And we can't rule out that there could be elements of embodied understanding inside these language models.
Exactly. And I think, in fact, we have some pretty reasonable evidence that suggests that they are, understanding things on a meaningful level. Like, my favorite piece of evidence here is from a paper. It used to be called Moving the Eiffel Tower to Rome. I think they've changed the name since then. But the thing that happens in that paper is that they do a small modification of the weights of a neural network. They identify the neurons corresponding to the Eiffel Tower and Rome and Paris, and then just swap things around. So now that the network believes that the Eiffel Tower is in Rome. And you might think that, okay, if this was just like, a bunch of memorized heuristics and like no real understanding, then if you ask the model a question, where's the Eiffel Tower? Sure, it'll say Rome, but it'll screw up a whole bunch of other questions. It like won't be able to like integrate that change into its world model. But actually what we see is that when you ask a bunch of downstream questions, like what can you see from the Eiffel Tower? Or what type of food is good near the Eiffel Tower? Or how do I get to the Eiffel Tower? It actually integrates that single change of the Eiffel Tower is now in Rome into answers like, oh, from the Eiffel Tower, you can see the Colosseum. Like, you should eat pizza near the Eiffel Tower. You should get there by taking the train from Berlin to Rome via like Switzerland, or, things like that. And so that
incredible.
Seems to me like,
That's
right,
incredible.
Exactly. And that seems like probably the best, almost like a definition of what it means to understand something, is that you can take that isolated fact and translate it into a variety of different ideas and situations and circumstances. And I think, this is still pretty preliminary work. Like, there's just like so much more to do here in understanding how these models are actually internally thinking and reasoning. But I think just saying that they don't understand what's going on, they're like just predicting the next word as if that's mutually exclusive with understanding the world. I think that's basically, not very credible at this point.
Yeah, that's a fantastic point. Who is currently working on developing general AI as opposed to specific applications of AI? Is that a meaningful question?
I think that at this point, language models in particular are becoming increasingly general, and so it's hard to distinguish any lab that's working on big language models from labs that are really aiming at generality, especially because a lot of people are interested in integrating like video or audio or a wide range of different modalities. So we're at the point where it's hard to give any like comprehensive list of groups that are working on general intelligence, and basically like any big AI lab, of which there are hundreds, are doing something that's in the broad direction of building general systems.
But I guess, some groups seem to be like self-consciously saying, we are on the path. We are marching towards producing an AI that can do almost everything or everything. So I think OpenAI is in this spirit, broadly speaking. And I guess DeepMind is in that spirit. They're like, we're going to solve intelligence, we're going to create general AI. Are there any other groups other than those two that perceive themselves that way?
I think it's a little tricky to tell. Like, one thing that I think people tend to overestimate is the extent to which the priorities at top AI labs are set by the explicit leaders of those labs as opposed to the researchers who are working within those labs. So, it's not really that clear to me what would be different about, say, Google Brain, for example, if the leadership had explicit priorities to build AGI as opposed to like implicit priorities like we want the best language models. So yeah, I guess that's a little bit of a harder thing to like really pin down. Like the other like clear examples are like Anthropic's, working towards general systems, and then Google Brain, Facebook AI research doing pretty cutting edge work as well. And then a whole bunch of other places that are like some that are more like startups, some that are more like labs attached to big companies, some that are like consortia of different countries working together, like in the EU, some in China, and so on. Yeah, it's really like a Cambrian explosion of AI right now.
Earlier on, we kind of gave more kind of general conceptual reasons, or the arguments that concern me about why positively shaping the development of AI is an issue that people should really be concerned about. But let's dive in now. Let's zoom in and get a bit more technical and think about exactly how models actually work, and talk about this paper that you wrote called "The Alignment Problem from a Deep Learning Perspective." Yeah, what did you want to communicate or add to the conversation with that paper?
A lot of the original arguments about AI risk were at a very high level of abstraction. And I think that's, pretty reasonable because like back when those arguments were being formulated, we hadn't gone through the deep learning revolution. We had much worse ideas of what it might look like for these systems to start approaching general intelligence. But now that we do, and now that we've made so much progress in deep learning, I wanted to see like how concrete we could get these scenarios where AIs like learn misaligned goals and then misbehave. Like how concretely can we convey these core ideas? And I think the way I ended up phrasing this was in terms of like the things that happen throughout a training process. So I'm imagining a large scale training process of a large neural network, and then thinking about, okay, as it becomes more and more competent, what might happen, and like what are the forces that are going to be pushing it towards acting in aligned ways versus in ways that are unintended and misaligned with human preferences.
Yeah. Remind me, what is a deep learning perspective specific? What's deep learning as opposed to other forms of learning?
Right. So deep learning is just the use of large neural networks, and in particular neural networks with like multiple layers, in order to learn from data. And that's basically, taken over the field of machine learning, especially over the last decade or so, where like basically any cutting edge system you'll see is a deep learning system that's got a neural network that's, somewhat analogous to the human brain, and that it has artificial neurons that are connected together, and the connections between those neurons are formed by learning from data. Yeah, so that's the basic idea.
Okay, yeah. So the deep is lots of layers of neurons, lots of parameters, bigger brain kind of.
Yep.
Okay, yeah. In the abstract of this paper, you wrote, the report aims to cover the key arguments motivating concern about the alignment problem in a way that's as succinct, concrete, and technically grounded as possible. I argue that realistic training processes plausibly lead to the development of misaligned goals in artificial general intelligences. In particular, because neural networks trained via reinforcement learning will learn to plan towards achieving a range of goals, gain more reward by deceptively pursuing misaligned goals, and generalize in ways which undermine obedience. Okay, let's go through those three issues one by one. Mm-hmm. Is it possible to explain in a not super technical way why it's a problem that neural networks trained via reinforcement learning will learn to plan towards achieving a range of goals?
Yeah, so I think this part is not a big problem in its own right. It's more like setting up some background concepts for how to think about these networks. So in particular, a lot of people think about the behavior of neural networks that are trained via reinforcement learning, which is, when they're given rewards and penalties based on their behavior. A lot of people think about this purely in terms of what rewards the system gets and like how that determines its behavior. So a lot of people will say, the goal of the system is to like get higher reward. And I wanted to focus on a more specific concept, which is the idea that these networks are going to have internal representations of outcomes. That is, within the weights of those networks, there are going to be some neurons corresponding to different concepts, and some of those concepts are going to be outcomes in the real world. And we've seen some examples that kind of move towards this so far. So like there are studies of neural networks that were used for image recognition, where they could identify the specific neurons that corresponded to like pictures of cats or pictures of dogs, or, different shapes, different angles, different textures, and so on. And so you could say, like, look, here's a model that builds up representations of cats or dogs or whatever by combining representations of shapes and textures and outlines and things like that. And so I'm just hypothesizing that this goes further, that it's not just representations of objects like these, but in these more general systems that are trained on a wider range of tasks, they're going to learn representations of actual real world outcomes, like, the human is happy with my performance, or I got to the end of the maze, or I won the game, or things like that. And then exactly how they're going to use those representations to choose actions, feels like a very open question. But the main claim I'm making here is just that, like, these networks are in fact going to learn these complex representations, and then those representations are going to feed into their actions via, some of them representing desirable outcomes and some of them representing undesirable outcomes. And then they're just going to learn to choose actions which tend to lead more towards the desirable outcomes rather than the undesirable outcomes.
Okay, yeah. So to have an example in mind that perhaps involves a bit more kind of agent decision-making, planning, and so on. I was looking recently at this blog post, I think from DeepMind, it's a couple of years old, where they were training a system to learn to play capture the flag, I think, in these kind of complicated environments. And I think they were working on it mostly because you'd have multiple different people on a capture the flag team, and they were trying to get them to coordinate. I'll see whether they could learn to coordinate. But it's okay. So in that case, you're saying, is it that these models, as they learn, they're going to develop sort of intermediate goals where, with capture the flag, the goal is to get the enemy, get the flag and bring it back to your home base. But it's going to have all these intermediate goals where it's going to say, have I managed to pick up the flag yet, or has anyone on my team picked up the flag? And then also, are two of us together? So if one of us gets killed, the other one can pick up the flag. It's going to have all these intermediate things that it's trying to accomplish because it knows that those are correlated with achieving the final goal. And then it starts developing plans to achieve those intermediate goals as kind of sub parts of its strategy.
Yep.
Am I thinking about this right?
Yeah, I think that's right, where there are just going to be a bunch of possible states of the game. And in fact, DeepMind did a bunch of work to identify which representations the capture the flag agent had learned, including things like my flag is at my home base or things like that. And then it seems like a relatively straightforward extrapolation to say, okay, well, how is it using that representation? Well, it's that representation of my flag is at my home base is somehow like guiding its actions towards, outcomes where that continues to be the case, where the flag isn't taken, for example. Now, in this case, I'm not going to say that agent is doing any like real planning necessarily. It could just have learned to act on instinct, basically, rather than reasoning about how to achieve those outcomes. And so the hypothesis here is just that as we get more and more sophisticated agents, the ways they're going to be aiming towards those outcomes is going to look more and more like they're actually doing planning, or like they're doing some kind of internal reasoning about how to achieve those outcomes. And then I guess there's a separate question of like which outcomes they're going to end up aiming towards. And the reason I phrase this in terms of a range of goals is because I think that, in the early stages of training, I don't think we can really say that agents are going to learn, any one specific overriding goal. In kind of the same way that, humans have lots of different drives. We have like the drive towards eating nice food. We have the drive towards exercising and the drive towards like succeeding and having people respect us and so on. And it's not really like you can say, well, all of these are just intermediate goals towards some one final goal, right? Rather, it happens to be the case that we've just got all of these internal representations of things that we like. Our actions are partly motivated by each of those. And so this seems like a pretty reasonable way to think about machine learning systems as they sort of start to approach human level, that they're just going to have a bunch of like representations of a bunch of outcomes that they've been rewarded for in the past, and they're going to take actions that, sometimes aim towards each of these different outcomes.
I see. So humans do this as well. So in some sense, we do have like broader, or like we do have kind of final goals in life to some extent, but then we develop all of these proxies that we're targeting on a day-to-day basis.
Mhm.
It's like at one level we don't want to starve, and then we use as a proxy. It's like, am I standing in front of an open fridge, or whatever other things we've kind of felt rewarded for in the past. But you're saying, I guess, as these models get more and more complicated, they're going to develop a bigger and bigger structure of these representations of different states in the world that they either have positive or negative associations with, and that those are going to end up doing a lot of heavy lifting and driving the actual behavior in any given situation. That's right?
Yep, that's right.
And why does that set off, should that set off red flags, or is that just setting up the situation for understanding more how they might behave in complicated ways?
Yeah. So I think early on in training, this is, a little bit worrying, but not crucial, right? So if I've got an agent that, has sometimes been rewarded for being obedient, but also has sometimes, gotten some rewards from being deceptive. And so it's learned the internal representation of like the concept of obedience, but it's also learned an internal representation of a concept like, hide mistakes where possible. Then like, in theory at least, if we are setting the rewards correctly, like over time, it's going to end up in situations where these two things conflict. And like, hopefully it learns to like prioritize obedience over, for example, hiding evidence of mistakes. But like, at least in the early stages, I expect that each of these things is going to be separately rewarded in a bunch of different circumstances. And so it's not going to be the case that they're just going to at least immediately converge just towards like one of these things. So I'm kind of picturing these agents that have learned a bunch of drives that are applicable to a bunch of different situations. And then I think, a lot of people would say, well, that's fine. We can just keep training them until they converge towards the only having the goals that we want. And that's when the next part of the argument comes in, where I'm saying, well, this is not in fact a reliable mechanism. Like we can't just keep training them until these correlations go away, because of the phenomenon I'm going to talk about next, which is situational awareness. And that's the second thing that I highlighted in the summary.
Yeah, so the second point was neural networks trained via reinforcement learning will gain more reward by deceptively pursuing misaligned goals. Can you elaborate on that?
Right. So the key idea here is this concept called situational awareness, which was introduced by Ajay Kotra in a report on the alignment problem, and which I've picked up and am using in my report. And the way I'm thinking about situational awareness is just like being able to apply abstract knowledge to one's own situation, and like in order to choose actions in the context that the agent finds itself in. And in some sense, this is a very basic phenomenon, right? So like when I go down to the grocery store to like buy some matches, for example, like maybe I've never bought matches at a grocery store before, but I have this abstract knowledge of like, okay, matches are the type of thing that tend to be found in these types of stores, and like, I can buy them, and like I'm in a situation where I can walk down to the store. So in some sense, this is just like a very basic skill for humans. In the context of AI, it's less like we don't really have systems that have particularly strong situational awareness right now. Like we have agents that play StarCraft, for example, but they don't understand, that they are an AI playing StarCraft. They're just like within the game. They don't understand the wider context. And then even if you look at language models, I think they come a bit closer because they do have this abstract knowledge. Like if you ask them, what is a language model? How is it trained? All those things like that. They can give you pretty good answers, but they still don't really apply that knowledge to their own context. Like they don't really use that knowledge in order to like choose their own answers. But then I think as we train systems that are just like useful for a wide range of tasks, like for example, an assistant, right? Like if you train an assistant AI, then it's got to have to know a bunch of stuff about like, what are my capabilities? Like, how can I use those capabilities to help humans? Who's giving me instructions, and like, what do they expect from me? And basically like the only way to have like really helpful AIs in these situations is for them to have some kind of awareness of like the context that they're in, the expectations that we have for them, the ways that they operate, like the limitations that they act under, and things like that. And that's sort of this broad thing that I'm calling situational awareness.
So there's this concept of situational awareness, which is it's the water that we swim in, such that it's almost hard to imagine that it's a thing, but it is a thing that humans have that lots of other minds might not have. But in order to get these systems to do lots of tasks that we're going to ultimately want them to do, they're going to need the situational awareness as well, for the same reason that humans do. So that's kind of a next stage. And then what?
And then when you've got systems that have situational awareness, then you start to get, I claim, the problematic types of deception. So in the earlier phases of training, right, you might have systems that learn the concept of like, okay, hide mistakes where possible, but they don't really understand, who they're hiding the mistakes from, exactly what types of scrutiny humans are going to apply, things like that, right? they start off like pretty dumb. Maybe they just have this reflex to hide their mistakes, kind of the same way that like young kids have a instinctive heuristic of hiding mistakes where possible. But then as you start to get systems that actually understand their wider context, like, oh, I'm being trained in this way, or like, machine learning systems tend to be scrutinized in this particular way using these types of tools, then you're going to end up in an adversarial situation where if the model tries to hide its mistakes, for example, then it will both know how to do so in an effective way, and then also apply the knowledge that it gains from the humans around it in order to like become increasingly effective at that. So that's the concern, that like these types of deception are just going to be increasingly hard to catch as models get more and more situational awareness.
Yeah, so that makes sense to me. Where is the badness slipping in here? So I suppose you've got a model and you're rewarding it. This model that you're conceptualizing is being rewarded, I guess, at the end of some process where the human says, yes, it did a good job. And then it realizes based on the situational awareness that it's better to lie about mistakes that it's made, for example, because that is one way that it can convince humans to say, yes, it did a good job. And so it develops a concept of, and indeed an intermediate goal of hiding mistakes that it makes. And then you might try to outwit that by checking its behavior, by checking its thoughts. But it has situational awareness. So it might see that you're using these tools, that you're using these approaches to try to root out deception.
Right.
And then so it's going to try to counteract that. It develops another concept for how it's going to get around those methods of detection. Am I understanding it right?
Right. And I think this is particularly important because, in the normal context of machine learning, you're implicitly assuming that we can just apply a whole bunch of like tests and safeguards and metrics and so on in a way that's not really adversarial. Like the sort of normal process of developing software or developing models and like figuring out whether we should deploy them does involve a whole bunch of checks and safeguards. And then the possibility of models being deliberately deceptive is a reason why all these types of safeguards that we might usually expect to prevent us from doing dangerous things with our models to like apply to a lesser and lesser extent over time.
So I suppose maybe this is just no surprise, really, because we're trying to make these models more and more human-like, to be more and more like human agents. And humans show these maladies where they develop their own intermediate goals that we don't like. They try to deceive other people. They notice conflicts between what they want and other people want, and then kind of can be a bit schemy. So perhaps it's just completely natural that in this process you would recapitulate undesired human behaviors.
Yeah, that seems right. Like, it's not like we're explicitly trying to make them more human-like. It's more like we're trying to get them to do a bunch of tasks, and then it just turns out that things like deception are robustly useful for getting higher scores on a wide range of tasks. Like, if we think about stock market trading, for example, there's some obvious metrics that you could use, like how much money have you made, but there's also less obvious metrics that we might be interested in, like have you done any insider trading or have you done any market manipulation? And these are the types of things where, a dumb system that starts to learn how to do some market manipulation is probably going to be caught pretty easily. But a system that has situational awareness could plausibly figure out, okay, these are the types of market manipulation that will be caught, and these are the types that won't be caught. And I'm just going to focus on the latter type.
Yeah. Is the original sin here that we're rewarding the system based on us saying, yes, we're satisfied, you did a good job? But that's not ultimately exactly what we want. What we want is to be satisfied and to have our preferences met. And that's not the same thing as pressing a button saying that happened. And so there's a bit of slippage between these two, and then all of these behaviors kind of appear in the crack between them, and it kind of pulls them apart gradually.
That seems right. And in particular, if we're trying to do this type of supervision for systems that are more capable than us in certain ways, like maybe can act more quickly, whose operations we don't really understand. Because, if you're trying to reward and penalize a kid, right, for teaching them what to do, then like a lot of the time this tends to work, at least in the short term. You can like mostly monitor them. But, in this case, it feels like significantly harder to monitor these systems as they start to get to the level where they can reason, as well as humans can about deception and about what's going to be caught and what isn't going to be caught.
Yeah. So I suppose, sticking with the child analogy, a 5-year-old isn't as smart and doesn't know as much as an adult, so their attempts at deception often get rooted out. I suppose not always, but
right.
but pretty often because they're likely to slip up. But then with another adult, they're in a much better position to try to trick you and get the better of you in an adversarial situation. And then if you had someone who's not very bright, dealing with someone who's really sharp and quite experienced, say, with deception, then maybe they're at a high risk of getting outwitted.
Mm-hmm.
And I suppose just for all of the reasons earlier, we were talking about how these systems can potentially advance quite quickly. You might think after a while, a trainer of one of these systems is going to end up in quite an unenviable situation trying to detect all of the cases where it's doing something that wasn't desired.
Yep, absolutely.
So it seems like to some extent people were reasoning about the possibility of kind of a tendency towards deception earlier, before we even knew exactly what machine learning systems would look like, before we had kind of modern architecture. Because you can also approach this at just a high conceptual level, saying, well, you've got goal X, you discover that you can get that using some hack that the other agent hasn't anticipated, and so you'll naturally start to do that. Is there anything in particular that we gain from looking at the systems that we have now and seeing, well, how specifically does that play out, rather than just how does that play out in a very abstract case?
I think so. I think, when you're reasoning about a system that already has some goals and it's just like learning strategies for doing so, or like trying to figure out strategies for doing so, then this feels different from a system whose goals are in some sense like being developed as it goes along, right? So a system that's, its goals are going to be changing on the basis of the rewards and the feedback that we give these systems. And so, you could imagine, for example, that if we like really penalize deception often enough while the system's not smart enough to deceive us properly, then it might just like learn the strong goal of like never deceive humans. And this might actually get us quite a long way. And so, so I think it's important to think about the process of us reinforcing certain goals of the system and that system trying to figure out novel strategies for achieving those goals as a process that happens in tandem, rather than just thinking about the limits of a system that already has fixed immutable goals and it's just trying to figure out how to implement them.
Okay. So is the idea here that we now see that the goal formation process of the systems is very messy. That's you put in some final goal, or you have some sort of reinforcement process where you kind of say how satisfied you were with the outcome. But this produces a lot of complexity internally in the behavior, and there's a bit of randomness in what gets rewarded and what doesn't. Is that kind of what's adding the additional insight that we can have today versus 10 years ago?
Right. And then also by like trying to pin this down, I hope that we'll be able to study it and actually understand what's going on better. So if we have the hypothesis, look, like the goals of a neural network are represented in this way, like maybe it has these concepts represented in the weights, and some of those concepts are wired up to others in certain ways, and that's what's leading to it choosing actions that are deceptive, for example, then, this seems like the type of work that could plausibly be done empirically on the systems that we currently have today, or systems that are not too far away from them. And then ideally, we'd then be able to, somehow modify or change the goals that these systems have learned in more desirable ways, perhaps in a way that's somewhat analogous to the paper I mentioned earlier of, changing the representation of the Eiffel Tower to be, linked to Rome rather than Paris. So that's like one example of like the more concrete we can get about what we mean by the system having goals, like the ways they're represented and the ways they're formed, the more possible interventions we'll be able to do.
Ooh, this is making me think. If you can find the neuron that fires that is kind of representing deception, then couldn't you, if you could flip it from kind of Paris to Rome, could you flip it from like mild positive association with deception to like maximally negative association with deception? Is that a crazy idea?
Right. That's, I think, the type of thing that, it would be very exciting to be able to do. And the bottlenecks are that, for these very high level sophisticated concepts like deception, it's just, really hard to know, like, have you actually found the neuron that represents it? Maybe there are like 20 neurons that represent it in like some complex way. Maybe it has a concept that's kind of similar to deception, but doesn't quite map onto the human concept of deception. So you're actually penalizing the wrong thing. Like these are all possibilities that we really have no way of figuring out right now. And we'll need like just a lot of further study in order to move towards that. But, at least if we can pin down claims like neural networks are going to choose actions on the basis of these internal goal representations, and here are some possibilities for what they might look like, then I hope that we can start to make progress towards that.
Yeah. So there's this general thing that, in a sense, these systems, as they're being trained, there's these like selective pressures, there's pushes towards particular tendencies. And here we've kind of identified a potential ongoing pressure towards deceptive behavior. And imagine if you tried to, so you find the neuron that codes for deception, and then you try to set it to be really negative. Well, just as like water, you can try to bottle water, but it just fills up and then tries to spill over, and it's always trying to get to its lowest point because it's attracted by gravity. Could you then kind of get an offsetting effect somewhere else in the model where it tries to now undo that? It tries now to find a new way to engage in deception that's coded differently and isn't being prevented by this mechanism. Is that a natural thought to have?
That seems right. Yeah. So then I don't think that any of these things would be sort of final solutions, but I think they're things that might allow you to leverage these systems to help you find better solutions. So like maybe if you have one model that you're pretty sure is not deceptive at a certain point in time, then you could ask that model, hey, are these other models being deceptive? If so, how or why? And then like start to leverage the intelligence and the capabilities of those models to supervise other models in turn. So it really feels like we don't have like solid proposals for arbitrarily scalable solutions right now, but we do have things that might be helpful on models that are plausibly human level, or maybe even like a bit more intelligent than humans. And hopefully we will be able to bootstrap our way into aligning much more sophisticated and much more capable models than we have today.
Yeah, set a spy to catch a spy. Okay, let's do the third one. What do you mean by reinforcement learning will generalize in ways which undermine obedience?
So the things that I've talked about so far, none of those are the core things that I'm worried about causing large-scale problems, right? So if you have a deceptive model, like maybe it's doing insider trading on the stock market, even if we can't catch that directly, over time, we're eventually going to figure out, something is going off here, right? As long as we like have this, maybe we're in a bit of a cat and mouse game where we're trying to come up with the correct rewards and the model's trying to come up with deceptive strategies. But as long as they're like roughly within the human range of intelligence, it feels like we can hopefully constrain a bunch of the worst behavior that they perform. And then I'm thinking, what happens when these models become like significantly super intelligent? And in particular, like intelligent enough that we just can't effectively supervise them. And what might that look like? It might look like them just operating way too fast for us to understand, right? Like if you've got an automated CEO who's like sending hundreds of emails every minute, like you're just not going to be able to get many humans to like scan all these emails and make sure that there's not some like sophisticated deceptive strategy implemented by them. Or you've got AI scientists who are coming up with, novel discoveries that are just like well beyond the current state of human science. Like these are the types of systems where I'm thinking, okay, we just can't really supervise them very well. And so what are they going to do? And that basically depends on how they generalize the goals that they previously learned from the period when we were able to supervise them into these like novel domains or these novel regimes. And so there are a few different arguments that make me worried that the generalization is going to go poorly. Because you can imagine, for example, that maybe in the regime where we could supervise, like we always penalize deception and they just learn very strong anti-deception goals. And maybe we just think that is going to like hold up into even quite novel regimes where deception might look very different from what it previously looked like. Instead of deception being, lying to your human supervisor, deception could just mean, hiding information in the emails you send or something like that. And I think there are a couple of core problems. The first one is just that as a field, the field of machine learning has very few ways to reason about systems that are generalizing and transferring their knowledge from one domain to the other. This is just not a regime that has been very extensively studied, basically because it's just so difficult to say, well, look, like you've got a model that's learned one thing. How well can it do this other task? Like what's its performance in this like wildly different regime? Because you can't quantify the difference between like Dota and StarCraft, or the difference between like speaking English and speaking French. Like these are just very difficult things to understand. So that's one problem there. Just like by default, the way that these systems generalize is in many ways totally obscure to us and will become more so as they generalize further and further into like more and more novel regimes. But then there are a few more sort of specific arguments as to why I'm worried that the goals are going to generalize in bad ways. And maybe one way of making these arguments is to distinguish between two types of goals. I'm going to call one type outcomes, and I'm going to call the other type constraints. So outcomes are just, achieving things in the world, like ending up with a lot of money, or ending up, having people respect you, or building a really tall building, or just, things like that. And then constraints, I'm going to say, are goals that are related to, how you get to that point. So what do you need to do? Do you need to be deceptive in order to like make a lot of money? Do you need to like hurt people? Do you need to go into a specific industry or take this specific job? Like you might imagine a system also has goals related to those constraints as well. And so the concern here is something like, for goals that are in the form of outcomes, systems are going to benefit from applying deceptive or manipulative strategies there. So this is, broadly speaking, a version of Bostrom's instrumental convergence argument, which basically states there are just a lot of things that are really useful for achieving large-scale goals. So, or another way of saying this is from Stuart Russell, who says you can't fetch coffee if you're dead, right? Even if you only have the goal of fetching coffee, you want to avoid dying because then you can't fetch the coffee anymore. And so you can imagine systems that have goals related to outcomes in the world. They're going to generalize towards, okay, it seems reasonable for me not to want to die. It seems reasonable for me to want to acquire more resources or, develop better technology or get in a better position and so on. And these are all things that we just don't want our systems to be doing autonomously. We don't want them to be consolidating power or gaining more resources if we haven't told them to, or things like that. And then the second problem is, okay, well, if these goals are going to generalize, right? If the goal, make a lot of money is going to generalize to motivate systems to take large scale actions, what about a goal like never harm humans or never lie to humans or things like that? And I think there the problem is that as you get more and more capable, there are just more ways of working around any given constraint.
Okay, so I'm just trying to follow all this. There was a lot there. Okay, so there's you form these kind of intermediate goals, and then you're gradually the systems are being scaled up to try to accomplish more ambitious tasks with more open-ended mechanisms. And then if they've learned intermediate goals that we don't exactly like, then they might apply those on a much broader scale. So the deception, for example, if we didn't give appropriate negative feedback to deceptive methods, then who knows what deceptive strategies it might adopt in future when it's given much broader goals, like run this company profitably and so on. And then, as you're saying, on the other hand, when you've got constraints where you're trying to code in things that a system is meant not to do, as it becomes larger and larger, there's more and more ways for it to wriggle out of those rules. Am I understanding that right?
That seems broadly right. I think maybe the thing I want to specify here is that at this point, we won't really have any ability to specify constraints or code things into the system. The only thing we can do here is while they're still under our supervision, we can try and reward and penalize various things they're doing. And then once they become smart enough that we just don't know what they're doing, don't know if this thing is good or bad, don't understand whether they're telling the truth or not, and sort of don't really understand at all how to figure out whether they're telling the truth or not. At that point, it's going to come down to which concepts they've learned. And if they've learned a concept like honesty or obedience, maybe they've learned a version of it which is never tell a lie, but there are many ways that you can cause harm without explicitly telling a lie. So you actually, when it comes to systems that have a very wide range of strategies because they're very intelligent for achieving outcomes in the world, my worry is that we're going to need them to generalize the constraints very broadly as well. So not just don't explicitly tell a lie, but also, don't mislead humans or don't work around humans without telling them what you're doing and things like that.
So the issue here is, I guess, we have this very kind of complicated set of actual underlying desires and so on. But we're feeding into the system in the training process more kind of binary messages like, yes, that was good, that was bad, that was good, that was bad. And it's trying to infer from that what principles it should be operating at, what means are acceptable in general, which ones aren't, what are the goals. And the problem is it's always going to be, it's going to come up with all these proxies. It's all of these guesses as to what we cared about.
Right.
But in as much as those aren't exactly what we cared about, then that leaves always a crack as it gets smarter and smarter and can come up with more and more strategies. So you're saying it might learn the general principle, don't actively deceive humans, because that is sufficient to explain all of the negative feedback that it's received so far. But that's not exactly what we get. That's only one thing that we cared about in this general space. We also cared about lying by omission. And so now, but now the door is open to lying by omission because it's only learned this far more constrained principle from the feedback that it got. And there's always going to be this gap, or we should expect that there always will be a gap between what we actually cared about and what it has been capable, what proxies it has been capable of inferring. And then as it gets more and more powerful, it will learn to drive a truck through that crack. Is that kind of right?
Yeah, that seems right. So there's one problem, which is we haven't covered all the proxies that it currently is capable of, right? So like, explicit lying versus lying by omission. But then you've also got the issue that as it becomes more intelligent, just a whole
more actions are available,
swathe of possible strategies, right? Exactly. Like maybe it has never been capable of lying by omission thus far. And now, like once it becomes intelligent enough, that opens up and you just don't know how the thing we've trained it to do, which is never lie, is going to generalize to this totally new capability, which, might be, lying in a different language, for example. Like if it's been only trained to like not lie in English and it learns French, is it still going to have the goal of never lying when it's speaking French? Like these are the types of things that we just like have no particularly good way of reasoning about right now.
Yeah. Okay, great. I think I've gotten the basic thrust of the paper now. I suppose we could keep on talking much longer about this, I'm sure. But people who'd like to get more detail can, of course, check out the paper online. That is the alignment problem from a deep learning perspective. I wanted to now have a bit of pushback, I suppose, because so far I've given you lots of space,
right.
and I've given myself lots of space to express reasons why we should be concerned about ways that things could go wrong. What are maybe the best arguments for thinking that this is all a bit overblown? I'm really alarmed about where AI might be in 10 or 20 or 30 years, but actually we should probably expect that things will be fine and will muddle through and the outcome will probably be good. What are the most reassuring arguments that one can offer?
So I think the basic reassuring argument is just like, most specific arguments about the future are wrong. It's really hard to, make concrete predictions when we're talking about systems that are very different from the ones we have today. And so, this paper has tried to be like as concrete as possible, but at the expense of, making claims that probably are just going to turn out to be wrong in a whole bunch of different ways. I think it's still useful though to like explore these claims because, even if the specific manifestation of the phenomenon isn't quite right, it still seems like there are some pretty robust underlying phenomena here. Like it's just useful to be deceptive, for example. That just seems like it's often true in a very wide range of contexts. And so even if the specific ways in which I've described systems being deceptive don't actually come out, it still feels like there's something worth investigating there. And so I think one principle that I think is pretty important is just it's harder to be right yourself than it is to prove other people wrong. And so, I think a lot of arguments that people have given for why alignment isn't important, I think are pretty weak, to be honest. Like, there are people who are saying things like, there's no such thing as general intelligence when, humans are clearly doing something interesting that allows us to do science and mathematics and build buildings and like build rockets and so on. And, if AIs do that same thing, like, sure, like maybe we shouldn't call it general intelligence for some specific reason, but whatever it is, like that still seems pretty worrying and interesting. And then I think, a bunch of other arguments that people have given for thinking that deep learning is totally on the wrong track to building general intelligence. I think, again, I haven't yet seen a version of those arguments that I find particularly compelling. And so I think that's enough to motivate looking into the problem ourselves. And that's enough to motivate saying, well, actually, this thing seems pretty important. I should work on it. But then, yeah, there's still a big jump from there to like, all of the specific claims that I make in this paper. So that's like one broad reason to be more optimistic, or at least to feel like pretty uncertain about what's going to happen.
Yeah. Okay. Is another way of framing this that, so, we've got all of these arguments in our mind about, our understanding of how these systems work, our understandings of how they might go wrong, but just it could be very easy for us to think that we've come up with a good argument of that type when in fact we have not, because it's just so hard to understand. And we're not very good at predicting future technology. And we're just not very good at thinking about and understanding how these AI systems work. Indeed, that's kind of the problem. But at least when we don't understand something and we think it's extremely dangerous, it's possible that we've misunderstood it because we just don't have a very good grasp on it. So that can be reassuring in one sense.
Yeah. And that seems like my current thinking is that line of argument feels sufficient to not be strongly confident in any particular claim about catastrophe, but at the same time, it's not sufficient to dismiss or discard the field, right? I think that like the arguments and evidence for AI posing significant risks are strong enough that people really should be focusing on this as one of the major issues, if not the major issue of our time. But while still realizing that there's just a lot of stuff that we don't know and a lot of like open empirical and theoretical questions that I've been trying to dig into, and I'm excited about many more people digging into.
Yeah. Are there any other things that somewhat reassure you?
Broadly speaking, the ways in which we can use language models to answer a bunch of questions without those language models themselves seeming like they're pursuing goals or like taking large-scale actions in the world is somewhat reassuring. Like, I think a lot of scenarios that I envision for how things go well involve us just using AI to answer a bunch of difficult questions, like how do we make sure to build systems in a more reliable and robust way, and just like getting answers from the AIs that we've trained to, do scientific research, for example. And so the further we can get on like scientific research type AIs without having AIs that are actually like acting in the world, trying to achieve goals, trying to like make money or like gain power or so on, the better I feel. So that's like one cause for optimism. I think the countervailing or like the response to that might be, well, look, sure, like these language models are good at answering questions, but actually it's not that hard to get them to start doing tasks. And we're kind of seeing this. I think there are some products put out by Adept recently, which is another AI lab that are trying to like leverage language models into performing more assistant type tasks. And so, maybe it's just the case that, okay, sure, like question answering is a little bit ahead right now of, general assistant style acting in the world, but like that gap is going to close.
I guess is another way of phrasing this that the more useful just these kind of oracle or like non-agent based models prove to be, the more you think, well, maybe that's what we'll pursue is systems that don't have situational awareness, that just spit back input output stuff in a way that doesn't feel like they're, I mean, I guess you're saying that there is a real blurred line between just doing input output and trying to act and change the world. However, the more useful the less agent seeming ones are, the more it's possible we'll just invest in that. And that's probably that's probably a somewhat safer approach.
Right. And the main thing I'm excited about, it's less like reallocating all the funding and research, because that seems pretty difficult. But just like, if it turns out to be the case that these capabilities are just easier than I expect, and it's just like we naturally get question answering systems that are at a superhuman level before we get superhuman CEOs or superhuman assistants, then that seems like a reason to be optimistic.
Yeah. A member of the audience wrote in with this question: much or most of the intelligence/power of humanity is contained in social and societal understanding. Does that mean that even something much more intelligent than a human might not be that dangerous?
I think it's some evidence in that direction, because it just feels safer to have more AIs that are each individually less capable than to have one big, totally inscrutable system that is just way more capable than any given human. Having said that, I don't think it's particularly strong evidence, just because, like, suppose that it's true that you need networks of many agents interacting with each other in order to produce very advanced capabilities. I don't see a strong reason why that means that those agents will then cooperate very strongly with humans, as opposed to like mainly cooperating with each other and shutting humans out of the picture, right? So I think that it seems that if humans are trying to maintain control of these whole like societies of AIs that are interacting with each other rapidly and like trading with each other, or like, building on each other's work, developing new capabilities together, this feels pretty worrying because we just like don't have the leverage in this situation. We just don't have we're like less intelligent, we'll think slower, we'll have fewer capabilities. And so I think it's a better situation, but not a good one by any means.
Yeah. Okay, so my reaction to this was thinking, so it is true that one person, however bright they seem to be, if they're just isolated and on their own, then they're not going to seem that smart. They're going to be struggling just to survive, I guess. Mm-hmm. So much of what makes us seem intelligent as individuals is all of this accumulated experience and knowledge and wisdom that we can absorb from others, and our ability to coordinate in big groups, in using strategies and structures that we've accumulated over centuries, and on and on and on.
Right.
So there's that angle. Of course, in as much like AIs that are acting in the world as part of human society on behalf of people kind of can leverage a lot of that as well. They're already part of a society. Mm-hmm. They're already part of organizational structures. So we bring with us to the table all of that existing situation. Mm-hmm. Another angle on it might be, so a single human who can only output the kind of amount of speech at any given time that a human can think. And they can only kind of think about one thing at a time, even if they're really smart, like significantly sharper than any human that's ever lived. Just with that level of processing capacity, they're going to struggle to overpower everyone else because they're massively outnumbered, and it's an extremely challenging task. So in as much as, let's say, we're in a situation where, okay, we've managed to train a model that actually is substantially more capable than humans at basically any task, and it can learn things pretty fast. However, we only have enough GPUs, we only have enough compute to run one at roughly human speed. Mm-hmm. Then I would think we got a really good shot that this thing is not going to be able to outsmart and outwit human civilization. The thing is that's not a situation that's likely to persist for terribly well. Firstly, probably we won't even be starting out that way at all, because we are going to have, I guess, what people call a compute overhang, where there's just going to be a ton of GPUs lying around that probably would be able to run many more instantiations than just one. Mm-hmm. But let's say that is how things started out. Then we're just going to we're going to quickly learn how to make more GPUs. Moore's law continues to operate, and then eventually we'll be dealing with a population of millions, kind of an AI society, mm-hmm. where each individual member is a whole lot smarter than any human that's around. And then eventually we will be back in a dangerous situation, though we will have bought ourselves, I suppose, more time in the meanwhile to figure out how to make these beings act cooperatively with us. Am I thinking about this straight?
Yeah, it does seem like we're on track towards the largest models having many instances of them rolled out. Like maybe, every person gets a personal assistant. And as those systems get more and more intelligent, the effects that they have on the world increase and increase. And the interactions that they have with the people who are nominally using them become much more complicated, and maybe it starts to become less clear whether they're being deceptive and so on. Yeah, so I think that's broadly right, that we don't really have mechanisms in place for steering towards, limited deployment of the most advanced systems right now. And I'm optimistic that some types of governance work, including the types of things that my team's working on, might be helpful for this, but we don't really have concrete solutions right now.
Okay. Yeah, well, let's push on to solutions. That was the next section header.
Amazing.
So those are some reasons to worry more or less about how advances in AI are going to play out. What is, I guess, your big picture strategy personally for how you are going to try to hopefully help things go better rather than worse?
So I guess this comes back down to the different strands of work that I outlined right at the beginning. So on the alignment front, just really trying to understand what the problem is, what we're up against, and what types of predictions we're making about how advanced systems will play out. I think just because we're working in such an uncertain domain, just having a better understanding of how the problems that phrased in intuitive language translate into concrete and specific machine learning concepts, that feels like a big step towards solving them. So that's my main priority when it comes to technical alignment work, is just finding ways to bridge the high level philosophical arguments with the concrete work that's being done on a day-to-day basis. And this paper that we've been talking about is one attempt towards that. And then hopefully I'm planning to do some follow-up work that makes it even more concrete, and hopefully to the extent that we can start running experiments to investigate some of the concepts that I've been talking about.
Yeah. So it's a little bit standing in the middle between, you've got kind of maybe high-level conceptual reasoning about how agents operate and how they could be made safe, and then turning around to the empirical results and how the models actually operate, and kind of switching back and forth between these two and trying to merge them into some plan for how to make things work well. Yeah.
Yeah, and I think just the field of alignment has done a surprisingly bad job at this in the past. I think people have just not really tried that hard to ground out these high-level concepts in concrete machine learning abstractions. And I think to some extent this is reasonable, because a lot of classic machine learning paradigms don't really account for things like systems that can generalize to new tasks, or systems that are neural networks that are doing internal reasoning in ways that we don't understand. These are just hard things to think about from a classic machine learning perspective. But I think it's still really valuable to bridge that gap, because just in order to make these arguments more comprehensible and spur on concrete research that, I'm pretty excited about. I'm pretty optimistic about the ability of humanity to like solve a problem once it's like laid out clearly in front of us. And so it feels like that's just a really big step.
Yeah. I interrupted you. I think you were going to go on to a second way you were hoping to help.
Yeah. And then when it comes to thinking more about governance and the ways in which we can implement regulations, again, I think the thing I want to do here is ground out these high level concepts and arguments, things like we should all coordinate in order to prevent the deployment of dangerous systems, and like trying to get really like specific, concrete examples of ways that people can contribute, like especially people with technical backgrounds. So maybe, I'll give a couple of examples of this. So I think one broad example is just doing research on chip level verification mechanisms such that we can try and produce chips that can't be used for certain types of particularly risky training. And that might just be because we can like monitor them, or like we can verify that they've been doing a certain type of activity, like maybe a chip that like can verify that it's been inactive for the past couple of months and so it hasn't been used on a certain type of training run. Or that could involve sort of more restrictive mechanisms, like NVIDIA has some restrictions on the way some of their GPUs can be used, so that you need to pay extra in order to unlock the ability to run many of them in parallel. And so that's the type of like hardware level restriction that, you know, some people have been thinking about, and like obviously people at NVIDIA and so on have been working on, but I think would just be great to have more people thinking about how to do this so that that can feed into more concrete plans for regulation and governance of AI.
Wow, yeah. I didn't know that sort of chip stuff was possible. Yeah, we should probably do an episode on that at some point if that's stuff that's really live. I know so little about the hardware side of any of this. I'm just like, it's chips. It's all chips just from my point of view.
Right. It's also not my comparative advantage, just in terms of my background isn't really hardware focused. And so I don't want to make particular claims about what is and isn't possible. Like, you know, there are some mechanisms that are in place along these lines, but also they can be circumvented. And so it's kind of hard to say, you know, make predictions about what would be effective at restraining particularly competent and motivated actors. But it sure seems like a set of research directions that I'd be excited about people looking into.
Yeah.
And then the second one I was going to mention is just like automated verification of certain properties of machine learning training runs. So if I have, you know, if I'm trying to train an AI and hopefully we'll have made some progress on figuring out like which types of training runs or which types of architectures or algorithms are like most likely to produce, for example, deception, and which like what mechanisms you need to put in place. Like how can we actually verify that this is something that's going on? One way could be for me to like show auditors the actual source code that I'm using for my training run. But, you know, that leaks all sorts of information. There are privacy concerns. And maybe it's just like hard to analyze that. Maybe there's just tens or hundreds of thousands of lines of code, and it's just really difficult for humans to look through that. And so it would be really great if we had better means of automatically verifying high level properties of certain training code, you know, things like how many parameters are being trained, for how long, using what types of algorithms. And, you know, I think that there's been some work done in these directions, but again, I think it's the type of stuff where it's very unclear how well that sort of work would stand up to, you know, attempts to break it by powerful and motivated actors. And so again, it feels like really an open question, like how far we can get in terms of automatically verifying properties of these training runs and the resulting models. So that's, again, a thing I'm pretty excited about people looking into, especially people with more of a background in automated verification and programming language design and things along those lines.
You're working on all of these things?
So I think the thing I'm trying to do is, as I said, like build these bridges. So like less specifically trying to scope it out myself and more like, well, here's what the governance people are saying would be useful for them. Like they want some ways of enforcing and monitoring treaties, and like using my technical background, here's some things that I think are like somewhat plausible and worth investigating, but like really I want to hand them over to the people who have like way more domain expertise and potentially serve as a bridge such that those people can say, well, actually, you know, what thing would be useful to have in these regulations? Like which of these things should we prioritize? Questions like that.
Fantastic. Yes. And all of this is happening kind of under the OpenAI banner.
Yeah. So the governance team at OpenAI has been thinking about a bunch of these high level questions and like working top down from, you know, what would it look like to be in a world where nobody was going to build specific types of risky systems to like, okay, and then what progress can we concretely make today to move towards that?
Yeah. Are there any technical approaches to dealing with the specific kind of path to misbehavior that you outlined in the alignment problem from a deep learning perspective paper? Are there any? I know people have had all kinds of different ideas for how you might shift how the training is occurring in order to prevent things from going in the wrong direction. Do you like any of them?
Yeah, so two of the approaches that I'm most excited about are firstly this approach called debate, which is an attempt to get AIs to monitor and supervise each other by training them to criticize each other's behavior and like report, ways in which another AI is misbehaving. And so far there have been there was a paper on this from Jeffrey Irving originally that outlined a bunch of the theoretical considerations mostly. There's been some more recent empirical work in this direction by the OpenAI alignment team. There's a paper on AIs critiquing each other, which, is starting to step towards AIs, automating the process of giving high-level feedback, which I think is pretty exciting. And so I think just like broadly speaking, it's hard to know how far this type of thing is going to scale because, eventually you're going to get into a regime where AIs are making arguments about each other's behavior, which is just very hard for humans to follow. But yeah, it certainly seems like something that we want to push as far as we can. And then, the second thing that I'm just very excited about is, progress and interpretability, because it just feels like the classic regime of, rewarding agents for behaving well and then just continually training them based on their behavior alone without really understanding what's going on internally is just like not a great regime to be in. And so anything we can do to move towards a more systematic scientific understanding of, when we give rewards in this way, here's the types of mechanisms that change within the neural networks. Here's like the types of ways that their representations shift. And here's how those representations correspond to these high level concepts. Like I'm pretty excited about that. A lot of that work is being done by Chris Olah and his team at Anthropic. And then an increasingly wide range of people, like, for example, the people behind the Eiffel Tower paper that I mentioned a while back.
Yeah. So the debate and the interpretability stuff, the AI safety opinion is very fractured on what strategies are promising, which ones aren't. And I know that both of those have their critics of people who think that there's just no way that either of these methods is going to pan out. Unfortunately, I don't know it well enough to know exactly what criticisms they would actually mount. But yeah, what would you say to a skeptic who is saying this interpretability stuff is never actually going to work? This is crazy talk.
I think my general response is just, it's hard to predict science, right? Like it's really difficult to know, what clever and motivated researchers can manage to do given, access to these big models. And there are all sorts of surprising breakthroughs that happen across the field all over the place. So I think, I think there's it does seem, important to have some debate about like how promising we think these approaches are at a high level to like help inform people who want to work in the field as to like which agendas they should focus on and things like that. But I think it's plausible that we're taking this too far and just actually we just need to like sit down and like really get as much empirical work as we can done until we hit the wall and then like keep reevaluating. And that just seems to be the way that, most progress in science has happened throughout history. And so, I'd maybe have more opinions if there were like some concrete trade-off that was involved, like, should we allocate resources here or there? But mostly I think people who see something exciting in a given research agenda and like think that they can contribute should choose mainly on that basis rather than on these like very high level considerations about whether the whole line of thinking about understanding AI systems is going to work out or not.
Yeah. You wrote this post on the AI alignment forum a little while ago called Some Conceptual Alignment Research Projects, which I guess was kind of a call to arms for people to investigate a whole lot of quite specific questions. Are there any that you'd like to highlight? And I suppose it was quite a long list, so people could go and check out the rest of them if people are keen to find an article to work on or a specific question to investigate.
The main ones I want to highlight are the ones related to the definition of goals that I've been talking about in this podcast, which is, goals are internal representations within a neural network of outcomes in the real world. And I think one, important aspect of this definition is that we don't necessarily know which networks have goals or don't. So, for example, if you take something like GPT-3, when it gives an answer, how far ahead is it thinking? Like, is it thinking about what's going to happen in the next paragraph? Is it planning out all sorts of long-winded responses? Or is it just thinking like a couple of words ahead? Like, we don't really know at this point. So like, I think there's some possible things that GPT-3 could be doing that would fit the definition of goals that I gave here. Maybe not like being a central example of goals, because it still probably wouldn't be thinking about how its actions affect the world in a very sophisticated way, but still like getting closer to it than maybe any other system has in the past. And that's just, an open empirical question. I can imagine a bunch of research being done, especially interpretability research, to try and hone in on that type of question. And even to just like pin down more precisely what that would even mean. There's some mix of like understanding these definitions and concepts better, and then like tying them to empirical, like to existing systems that I'm generally very excited about.
Yeah. Is there, I guess we've been talking about things that you think are good. Is there any work that you think is overrated, at least by the people doing it, that you're willing to tell us? It's always a little bit edgier to say that things are overstated. But
yeah. So I do think that none of the existing books on the alignment problem, including Bostrom's Superintelligence, Russell's Human Compatible, and then Brian Christian's The Alignment Problem, none of them really get at the key thing that I care about, and which I've been trying to convey in the paper that we've been discussing. And that's for a range of different reasons. Like superintelligence doesn't really focus on like modern machine learning and deep learning, which is understandable given when it was written, but feels like it dates it today. I think human compatible, I think the framing resonates with some people, but the way that Russell frames his solution to the problem, or his like overarching agenda to solve the problem, just like really doesn't resonate with me. It feels like it relies on a bunch of assumptions that aren't really made as clear as they should be. In particular, assumptions about, for example, like how well are we going to understand the systems that end up being generally intelligent? And I think Russell's paradigm for solving the problem works if you think that we're going to make a whole bunch of progress on cognitive science and neuroscience, and we're going to like be building AIs that build on that knowledge in like some quite specific ways. But in a regime where like that we're currently in, which is where, taking very large black box systems and just throwing a whole bunch of compute at them, it doesn't really feel like the right type of approach. So that's something that I think he's overclaiming, or at least not identifying his assumptions as clearly as he should be doing.
And what were you saying about Brian Christian's book, The Alignment Problem? I guess that wasn't setting out an approach to solve the problem. It was more just trying to explain the problem well. Yeah,
I think it's a pretty great book, and it just mostly doesn't deal with the alignment problem as it might manifest in the regime of human level and superintelligent AIs. And I think that's a very reasonable thing to do, because that's much more speculative and much more difficult to discuss. And I think he covers very well the alignment problem as it exists in systems today. But the thing I'm concerned about, or the thing I'm most concerned about, is the manifestation of the alignment problem in these like highly advanced systems. And so I think the book just has relatively less to say about that.
Yeah. Okay. That kind of wraps up our solutions section. I suppose, as always, it's just we could keep on talking about this stuff forever, but we can only take up so much of your time, and I suppose only so much of listeners' time on any one particular episode. As we head towards the end, let's talk a bit about how you managed to get into all of this in the first place. I suppose it's intrinsically interesting. It's an interesting path, and plenty of listeners, I imagine, are interested in making a career shift either into AI or some other thing that they have not yet engaged with. What were the most important inflection points in your career so far, in your mind?
So I guess first reading about the alignment problem when I was in high school, actually, on Less Wrong, that laid a bunch of seeds, which I didn't really do anything about for the next few years. But when I ended up going to undergrad at Oxford, I got involved with effective altruism, and then slowly meandered my way towards this career. In hindsight, it took me way longer than it should have, given like my beliefs and interests.
Yeah, when were you first reading about it?
This was in 2010, maybe.
2010. Okay, yeah. So you were reading about it in general for quite a number of years before you were seriously thinking about taking any action. Yeah, I guess that is an unfortunate delay. Although I suppose it's the alternative thing is to end up getting like bounced around all the time by things that you end up reading, constantly changing plans, having being a bit too volatile, which I've also seen people do, and can also be a mode of failure.
Right. I think at the time I was just too conformist, and also hadn't really been tracking progress in AI, which I think, at the time was still confined to the discipline and the academic field way more than it currently is, where like everything's being released to a lot of media attention and so on. So yeah, it took me a little while to like get out of that rut. And I think, there are some friends from my time studying in the UK who are really helpful with that.
Fantastic. Yeah. So, yeah, how long did it take you to start seriously contemplating doing something?
So I was sort of learning about AI all the way through undergrad. And then I think another inflection point was just during my master's, where I was basically, focusing on machine learning, like engaging with some of the cutting edge research, and felt like that was a big shift from, being in the mindset of consuming knowledge to the mindset of like trying to produce knowledge, even that if that knowledge was just, summaries of the latest papers and like trying to puzzle my way around what was actually going on with these systems. So yeah, that felt like a big shift. I think in hindsight, again, that could have happened in undergrad. There was no real reason why it had to be in my master's that I shifted into actually engaging with cutting edge research. But yeah, especially in the UK, I think people tend to start doing research a little bit later. In the US, like it's fairly common for people to get research internships, maybe even in their like first or second year of undergrad. Whereas in the UK, people are a bit like often save it until their masters. So that's just one thing that people, especially like in the UK and other countries, should keep in mind, that there are often a bunch of research opportunities earlier on than you might expect.
Yeah. So what were some of the first steps that you took, and maybe what pushed you over the edge?
So the steps I took, I just started reading papers, trying to summarize them, trying to figure out what I thought of them and where they could be improved and things like that. Implementing some papers and implementing some projects as part of my master's. And then the two things that shifted me into working on this full time were an internship at the Future of Humanity Institute, and then a job offer at DeepMind on the alignment team there. And yeah, so I joined DeepMind straight after my master's, or like after the internship, and yeah, spent 2 years there total, where like the first year was, just getting up to speed and doing a bunch of engineering mostly. But then the second year was really trying to focus on understanding the problem a bit better, and like the lines of work that I've been talking about today and have been working on throughout the last couple of years.
Yeah. What made you leave DeepMind and go and start the PhD?
So I think I was officially a research engineer at DeepMind, and the type of work that I was thinking about and the type of work that I've been talking about here are like, less engineering work. And, I think it seems possible that I could have sort of found a place for it at DeepMind, but it wasn't really a central example of the thing that I'd been hired to do. And it felt like I could do a bunch of that thinking as part of the PhD with a bunch more like time and freedom and so on, which turned out to be like true in some ways. And then of course you face trade-offs by, not being at the cutting edge of the field anymore. And so, not having access to the biggest models and not really hearing a bunch of the discussions that are going on inside these top AI labs. So, I think the PhD, it would have been a reasonable choice to finish the PhD. But when the offer from OpenAI came along, I think it's just like, it was significantly better for me personally.
Yeah. So hold on, but you started the PhD. What was the main motivation there? Was that kind of you wanted credentials in order to further your career, or you thought like it was really important to learn this stuff that you could only learn when you had time to study in depth?
I think it was, I wanted to spend time thinking about these questions, and I thought, well, I may as well get a PhD out of it.
Yeah.
Especially because PhDs in the UK, they're very short. They can be 3 years compared with 5 or 6 years in the US, and you can basically just dive straight into your research project. So and like getting a bunch of mentorship from people who are like in my case, who were mostly thinking about philosophy of science and like sort of less AI knowledge, but like very careful thinkers. So it felt like a good opportunity for me at the time.
Yeah. Do you think it was a reasonable decision in retrospect?
Yeah, I think so. And I think, a lot of the time you get most of the value out of, the first year or so of a given thing. And so, I think I got a bunch of value out of trying to like lead my own research and like be more careful in how I approached a bunch of like thorny conceptual problems and so on from the PhD, in a way where, probably there would have been diminishing returns from staying for the second and third and potentially fourth years. So in hindsight, I'm like reasonably happy with how that turned out. Although, there's a type of energy and like pace of progress that happens over in California, which, is always good to get access to earlier on, maybe.
Okay, so what was the situation when you decided to bounce from the PhD after a year or so? You're thinking, I've been here for a year, I've learned a bit of what I can from this, and I guess you had a job offer from a place which was kind of the sort of place that you would want to go when you finish the PhD anyway.
Exactly.
I see, yeah. And you're like, wow, okay, why would I stick around for another 2 or 3 years when I can just go do it right away?
Yep.
Yeah, do you think in general too many people stick it out in PhDs that aren't serving them?
Yeah, it's hard to say because, the base rate of dropping out of PhDs is pretty high. So it's hard to make a strong judgment either way. I do think that the credential of a PhD is just becoming less and less important in machine learning in particular because, there's just a massive talent shortage. And so places like OpenAI and Anthropic in particular are very open to having, research leads or even heads of big teams who just don't have PhDs or even undergrad degrees sometimes. So I think the field is pretty meritocratic in that sense. And so there are a lot of opportunities out there for people. So yeah, maybe in the specific domain, it does seem like people are plausibly sticking to PhDs longer than they should, but that's not a particularly strong opinion.
Yeah. Yeah, it's not uncommon among people I know that someone gets a couple of years into their PhD and by that stage they are qualified for the role that ultimately they want to get when they graduate. And so if they could go and do it, but then they feel like they'll be wasting all of the stuff that they've done so far to not stick around for another year or two, and potentially go through the what's kind of the slog maybe at the difficult end of a PhD when you actually have to put it all together and get over the line. I suppose, yeah, maybe you didn't face a very difficult decision with this one because it seems like a PhD is just not such an important credential, not such a key issue in machine learning. And perhaps people face a somewhat more challenging decision when maybe in the long run, they're not sure whether they might need the PhD because they're in an area where it gets you greater kudos.
Right. Yeah. So I think, my situation was unusual in a bunch of ways, including the fact that I was doing this sort of more philosophical work on the philosophy of machine learning and these high level questions there, that it feels like that's a pretty unusual path and it's a little hard to infer generalizable lessons.
Yeah, totally. Are there any mistakes though that you've made that you think could be instructive for some listeners potentially?
Right. So being too conformist, especially during undergrad, that made me slower to focus on things that I already agreed were important problems.
Yeah.
I think maybe just assuming, not focusing enough on just continually learning about the cutting edge of the field, just thinking that, okay, great, I'm working, my day-to-day is as an engineer or my day-to-day is thinking about these governance stuff and I can spend less time on really deeply trying to understand a new thing that came out. Obviously, the things that just came out yesterday, it's hard to tell which ones have staying power or which ones are going to last. But I think just focusing on continually learning seems like a pretty good heuristic that, it's easy to just get a little bit lazy and then not get around to that.
So, I mean, each of us only has so much time to kind of stay abreast of things that are going on, both in our field and in the world as a whole. Just staying generally informed. Why do you think you're kind of undervaluing what you get out of just keeping abreast of new technical results?
I think in this field in particular, people get into alignment because they're paying attention to these high-level abstract arguments. And so we're selecting for people who have a certain tendency to focus on this particular style of thinking and then end up having a bias towards, being a bit less interested in, okay, but actually how did that latest result, how did that work? How did they make that happen? Yeah, so I think that's my guess, that people underrate the extent to which deep technical familiarity is actually going to have sort of surprising or non-obvious returns by sparking insights or reframing the way you see a certain phenomenon.
Yeah. Okay. Yeah. Is there anything else you want to say about your career that might help steer people in the right direction, or should we push on?
I think personally, I've been very curiosity oriented, and that's paid off pretty well for me. Especially when you're younger. It seems like trying to coerce yourself into doing things that you're not interested in is a tricky prospect. And, maybe it pays off for people who are more conscientious than I am. But I do think that where possible, if you can find some pathway to just being really excited and obsessed by a research direction, that's the thing that's most likely to have really strong payoffs down the line. Yeah. And it's hard to say. Obviously, in some sense, I'm very lucky because I find the stuff I'm doing really fascinating while also thinking it's very important. And this feels not a coincidence. I find it fascinating partly because it plays into such big picture issues that are of such potential significance. But yeah, I do think people should spend more time trying to find ways in which they can hook the thing into their brain so that it's like feels less like forcing themselves to study it and more just like, oh yeah, this is what I want to spend my time thinking about in general.
Yeah. Okay, yeah, we're almost out of time. But one of the non-AI blog posts you've written, which I really enjoyed reading this week when I was prepping for the conversation, is called Characterising Utopia. Can you tell everyone, what challenge with utopias were you trying to address in writing that?
So it seems like people have kind of branched off in two directions when thinking about utopias. One of them is the sort of transhumanist direction, like we're going to have all of this amazing technology, we're going to enhance ourselves radically, like life will be unrecognizable. And then the other direction is this like very communitarian approach, like utopias like Island by Huxley or Walden 2 by Skinner, where they're really focusing on the ways that people relate to each other and the ways in which fundamental human relationships are reshaped. And it just feels to me like, actually, why not both, right? Like probably the world is going to be dramatically changed by technology, which also allows us to like have better interpersonal relationships and like have deeper connections with other people, which is like the stuff that, you know, fundamentally most people care about most deeply, the relationships with others. And so one of the things I was trying to do here is just see, well, can I actually describe a utopia in which like, sure, we have like all this advanced technology, but like that's not actually the main thing for people. The main thing is that like it allows them to live like richer, more fulfilling lives in a like social and relational context. And, you know, I threw out a bunch of ideas and haven't really managed to stitch them together into a cohesive picture. But I think this is the type of thing that I think people should be thinking about more. Just being able to actually interact with each other and have technology facilitate the things that are most meaningful in our lives, rather than just picturing either relationships without technology or technology without relationships.
Yeah. So, some of the shifts that you envisaged wouldn't be super surprising. Like we could reduce the amount that people experience physical pain, and we could make people, you know, be a lot more energetic and a lot more cheerful. But you had a section called contentious changes. What are some of the contentious changes or possible changes that you envisaged in a utopia?
So one of the contentious changes here is just to do with individualism and like how much more of it or less of it we have in the future than we have today. Because I guess we've been on this trend towards, you know, like much more individualistic societies where like there are fewer constraints on what people do that are externally imposed by society. And I could kind of see this trend continuing, but I could also see it, you know, going in the opposite direction. Like, you know, maybe, for example, in a digital future, we'll be able to make, you know, many copies of ourselves. And so this whole like concept of my personal identity starts to shift a little bit. And maybe I start to think of myself as like, not just like one individual, but like a whole group of individuals, or like this like larger entity. And in general, it feels like, you know, being part of a larger entity is like really meaningful to people and really shapes a lot of people's lives, like whether that's religion, whether that's communities, families, things like that. And the problem historically has just been that you don't get to choose it. You just have to like get pushed into this entity that maybe isn't looking out for your best interests. And so, yeah, it feels interesting to me to wonder, like, if we can in fact design these larger entities or larger superorganisms that are really actually good for the individuals inside, as well as providing this more cohesive structure for them, like, is that actually something we want? Would I like be willing to lose my individuality if I were part of this group of people who were, for example, reading each other's minds or just like having much less privacy than we have today, if that was set up in such a way that I found it really like fulfilling and satisfying? And I really don't know at all. But it seems like the type of question that is really intriguing and provides a lot of scope for thinking about how technology could just change the ways in which we want to interact with each other.
Yeah. I'm so inculcated into the individualist culture. The idea just it slightly makes my skin crawl thinking about any of this stuff. But I mean, I think if you try to look objectively at what has caused human well-being throughout history, then it does seem like a somewhat less individualistic culture where people have deeper ties and commitments to one another. Maybe that is totally fine, and I've just drunk the Kool-Aid thinking that being an atomized individual is so great.
If you know the book, The Weirdest People in the World, which describes the sort of like trend towards individualism and like weaker societal ties, you know, I think the people in our circles are like the weirdest people of the weirdest people in the world.
Yeah.
Where weirdest here means, you know, it's an acronym meaning like Western, educated, industrialized, rich, and democratic, not just weird. And, so we're the weirdest people of the weirdest countries. And then, you're not a bad candidate for the weirdest person in the weirdest community in the weirdest countries that we currently have, Rob. So I'm not really too surprised.
Definitely out there on the tail. Yeah, I mean, I think a case where this comes up is talking to people who have grown up and live in countries where it's totally normal to continue to live with your parents into adulthood, into your 20s and 30s, potentially even 40s, until you get married. And I've asked a bunch of times, do you find this frustrating? Because I got on really well with my parents, very happy with how they raised me, but the idea of having them up in my business, and I think for them, the idea of me being in their business, it's just very, very, very unpleasant idea. We really want to have lots of our own space, but mostly I've actually just gotten back blank stares. We're like, why would that be a problem? I don't understand. What's wrong with living with your family? It's great. And I mean, that was far more surprising than any other specific answer that I could have gotten about how it was. What are some other contentious changes on the list, if there's any others you'd like to highlight?
So this one's not on the list, but I feel pretty interested in just like how weird virtual reality could be. Because like right now, we kind of imagine VR and like, Meta is imagining VR as like, you can wander around in these 3-dimensional space that kind of looks like the real world. And there are some games that, maybe have a little bit of time travel or like a little bit of 4-dimensional stuff. And I'm just like, man, it seems like the sky is really the limit here, or not even the sky, but like, could we have like just totally different dimensions, totally different senses in virtual reality? And like, especially like if you're a kid just playing the latest VR games, I could totally imagine that you just grow up and you've been playing these like 5-dimensional games for your entire childhood. And like now you just can think, you can like mentally rotate 5-dimensional shapes and just like you could do the types of mathematics that we currently can't even dream of. Is that a good thing? Again, really feel very uncertain about whether I think I personally would love to have grown up like that, because it's just like, so intriguing to grow up learning very naturally about this like fundamentally alien mental possibilities. But, I can imagine that being pretty controversial as well. But I just think that like there's just so much scope for like designing these weird and wonderful worlds that we've really like barely explored even a fraction of the possibilities, let alone implemented them.
Yeah. Were there any other changes in there which you think wouldn't be found in many imagined utopias, which you think are kind of distinctive to your list?
I think that people in science fiction have generally not been very creative with like imagining new social roles. So, we have all these archetypes of different personalities and different like gender roles, for example, and people have just been pretty bad at designing their own. And, I think that's somewhat understandable, because like it's much easier to imagine new technologies than it is to rethink the fundamental ways in which humans interact with each other. But it seems to me that we could, in fact, just end up with people who have new norms or new, like radically alien norms that are as basic and fundamental to them as like our most basic norms, like the family norm, for example, or the friendship norm. Yeah. And it's just like, I don't really have great examples of this to give, because I don't think people have really been thinking about them that much. But like, for example, like the whole conception of romance, for example, that feels like something that is pretty modern in a historical context. And like, if we imagine ourselves transported into a future where romance just looks totally fundamentally different than it does today, I wouldn't be surprised, but I would end up very confused and like have no idea how to orient around that. So yeah, I'd love to read more stories like that. And, maybe we'll get the language models onto writing them soon and see what happens there.
Yeah. Well, the blog is called Characterising Utopia, and it's on your blog, which is titled Thinking Complete. There's plenty more in there. It was quite a long one, so if people enjoyed those 3, they should go and read the whole thing. One final question. So one of my favorite questions for people at parties. What's your favorite thought experiment ever?
Yeah, I am a big fan of alternative history thought experiments. So, it feels really intriguing to me to wonder, for example, like why did the Roman Empire not industrialize? Because, they had a bunch of the technology, they had a bunch of the materials and so on. It's just like, what's the like smallest little push that you can imagine that would start them rolling down the slope towards like a fully industrial society? And, that's just like kind of fun to play around with. it's not very clear if we can ever have an actual answer to this, but it feels like these types of questions are, just like really fun to like try and figure out what's actually causing, like, how did we actually get so lucky? Or were we in fact lucky? Was it like really overdetermined that the world would end up in the current state that it is? And then like going back even further, like, why did we even evolve the way that we did? Like we've got humans and we've got plants, and like, what's the smallest change that you could make that would end up with the biological world looking like totally different to how it currently does? One which I put out on Twitter a while back actually was something like, if all animals went extinct, how long would it take for plants to evolve to start like chasing each other around? Because now there's this new like niche in the ecosystem, which is like carnivorous creatures. And like, it feels kind of crazy, but also it only took
it's not crazy
animals
what's
a
already
few
happened.
100 million years. Right, exactly. And it's just, again, it's not really the type of thing that we can like properly know the answer to anytime soon. But I think it highlights just like how radically contingent a lot of the stuff could have been, and like how little we know about the forces that actually led us to where we are today. And so that's always like a fun thing I enjoy thinking about.
Yeah. Just turning back to the Roman one, there's some science fiction book about someone who's somehow accidentally sent back to Roman times, right? And they have to figure out how to make their way. What's that one called?
I don't know that one. I think there are a couple that are about what happens if the Romans end up taking over the world. But I'm nothing's coming to mind.
Okay, well, people have told me the science fiction book is good, so we'll figure out what it is, and we'll stick up a link to it in the blog post associated with the episode. Yeah, one of my favorite thought experiments is very similar concept, but it's imagine that you were unexpectedly sent back to 200 BC. Would you be able to convince people that you were from the future just based on that you can't bring anything? You can't bring any artifacts like an iPhone or something, but would you just with your knowledge be able to convince them? I've heard people argue no, but I think the answer is just very clearly yes. Well, either you could persuade them either that you're from the future or you're from somewhere very weird, where you've got knowledge that's far beyond what they have and very unexpected. But I think I'll leave that as an exercise to the reader. All right, my guest today has been Richard Ngo. Thanks so much for coming on the 80,000 Hours podcast, Richard.
Thanks for having me, Rob. Love the discussion.
As always, we list a range of jobs related to all things to do with positively shaping the development of AI on our job board at jobs.80,000hours.org. There's about 100 of them up there at the moment. Before we go, Richard designed this course called AGI Safety Fundamentals, and after the episode, he wanted to add a few remarks to tell you all about it in case some of you might like to sign up. Here's Richard.
AGI Safety Fundamentals is a course I designed with the goal of helping people learn about the alignment problem and some of the research directions which are aiming to solve it. It's an 8-week course, and each week you have a couple of hours of readings and then a small group meeting with 4 or 5 other participants and a facilitator who have a discussion about the readings and the ideas that came up and any confusions that people had. It's intended for a pretty wide range of audiences, so ideally people would have some background in a technical subject like computer science or mathematics, but you don't need any machine learning background. We've had people who are just totally new to machine learning. We've also had people who are professors in machine learning and who mainly want to understand, what's going on with the field of alignment. And we stream those participants into different groups depending on their level of expertise and how familiar they are with the problem overall. We're running the next round of that in February this coming year. And so if you want to apply for that, which I recommend as a way to learn more about the alignment problem, the deadline is the 5th of January, and you just want to go to agisafetyfundamentals.com for that. We've also got 2 other courses which we run alongside that. One is the AI Governance Fundamentals course, which is a bit less technical and a bit more focused on the political and governance problems involved with the development of advanced AI. And then the other one is the Alignment 201 course for people who have already taken the Alignment Fundamentals course. Those ones aren't being run quite yet, but you can go up to the website and find the curricula for each of those and work through it yourself or with a small group of others if you want to do so.
Okay, Rob again here. Thanks for that, Richard. One final announcement before we go is that Peter Hartree, who used to work at 80,000 Hours, has recently launched a new podcast feed that features human-read audio versions of popular or particularly significant posts from the Effective Altruism Forum, which might naturally be of interest to some regular listeners to this show. If you want to search for that and subscribe, the name of the feed is EA Forum Podcast, and then all audio in brackets. And naturally, I imagine you can find it in any podcasting app. All right, the 80,000 Hours podcast is produced and edited by Kieran Harris. Audio mastering and technical editing for this episode by Milo Maguire and Ben Cordell. Full transcripts and an extensive collection of links to learn more are available on our site and put together by Katie Moore. And now, for the first time, I can also add that our theme song is La Vita è Bella by Jazz Enough. Thanks for joining. Talk to you again soon.